we still have people trickling in. All right. Oh, that's a little close. Good morning, everybody. Welcome to day 2 of Rejekts. Hopefully Salt Lake City is treating you well. Little run through on this morning. We'll have some sessions until lunch. I'll be your moderator if you have questions when we get to the end, if you have questions, just kind of raise your hand and I'll bring the microphone around and make sure that everybody on the live stream and in the room can hear you. We're going to start in this morning with a deep dive, collect and process your logs on K8s with OpenTelemetry with Christos Markov. Let's go.
Okay, thank you. Morning, folks. Thank you for joining this early morning session. So we already mentioned the topic. It's about collecting and processing logs on Kubernetes environments using the OpenTelemetry collector. First of all, my name is Christos Markov. I'm a software engineer at Elastic, and I have been dealing with observability for 5 years now. And since last year, I have been spending most of my time working on the OpenTelemetry ecosystem, specifically on the collector and the semantic conventions projects. So before we start, a quick reminder of what OpenTelemetry is. For those that are not quite familiar, we know that it is an observability framework, and I like to think of it as a set of specifications and implementations for observability. So with OpenTelemetry, we can instrument our applications using the language-specific SDKs in order to start collecting telemetry signals from them. Then using the OpenTelemetry protocol, we can transport them to another component, for example, the OpenTelemetry collector, which can receive, process, and export OpenTelemetry data to a remote or an observability backend specifically. These signals are usually traces, metrics, logs, and profiles, and they follow the semantic conventions, rules, and guidelines. At the same time, we can have the collector running on the edge, which means that the collector is responsible for collecting telemetry data from target systems or from the edge host directly. So with OpenTelemetry protocol, we can describe logs using the specific definition that the protocol provides. So for example, to describe a log, we have a specific field in the structure to put the body of the log, another one to describe the severity of this log, and we have specific space for storing additional attributes which follow the semantic conventions. And on the resource level, we can add additional resource attributes which describe the resource that is related to this emitted telemetry. And resource attributes and attributes are following the semantic conventions, and the resource log is whatever the protocol defines. So in a simplified version, the OpenTelemetry protocol is a protocol buffer schema definition, which is implemented over gRPC and HTTP. So the collector is one of the most important components in the ecosystem, the OpenTelemetry ecosystem, and can be used to receive data, process them, and export them to other systems. We can use the collector as an agent on the edge, as we mentioned before, and we can use the collector as a gateway in order to receive data from other components like the SDKs. So the collector consists of pipelines that we configure, and a pipeline consists of a receiver which receives the data. Then we can have one or more processors in the pipeline in order to further process the data, and then we can export this data to another system or to an observability backend. So in order to collect container logs from Kubernetes environments, we can use the collector to read the logs directly from the files on the disk, or we can use the OpenTelemetry SDKs to instrument the applications and start capturing their logs. The Kubernetes documentation specifically suggests this architecture. One of the architectures that are suggested is this one, where the applications running as containers write their logs to the console, standard output or standard error, and then the container runtime is responsible for writing these logs down to a file which is stored on the Kubernetes node on the disk. This means that if we have a collector or an agent with access to this specific file, we can start watching this file and collecting the logs from this specific file. We can further process them and send them to a login backend to store them permanently. So that's exactly what we're doing with OpenTelemetry collector. We have the pods, the containers, writing their logs to var logs var log pods directory of the Kubernetes node, and then the daemon set collector that runs on the same node has access to this directory because it mounts it as a host path, and then it can collect all the logs that are written there from all the containers that run on the specific node. The collector now has a specific receiver for this job, for collecting logs from files, which is called file log receiver. So with file log receiver, we can specify which files we want to watch and which files we want to collect the logs from. It's this include section there, and we can also define additional set of operations which are performed by the operator section here. So in this example here, we can define a regular expression parser, which in this example, receiving this input on the left, will parse it using the regular expression, and it will export what is on the right side, which means that some specific content from the log line is exported to specific and stored into specific attributes like the host, the type, and the timestamp as well. Now with container logs, we mentioned before that the container runtime is responsible for writing the log from the console down to a file. But the interesting part is that the container runtimes also wrap these log messages into specific formats. So in case of Docker runtime, the log message is wrapped into a JSON struct and ends into the log key of the JSON struct. And we also have additional information like the stream, standard output, standard error, and the timestamp as well. For other runtimes like CRIO and containerd, we have other formats, and we would like to have a way to properly parse these formats and extract this information, store it properly in the fields that the protocol defines. So in case of Docker runtime, for example, we want to export the log, put this on the body of the log record, and same for the rest of the keys there, like the stream, store it as an attribute, the timestamp as well. So in order to achieve this, we can define this configuration for the file log receiver, which consists of a set of operators in order to identify the runtime properly, and then regular expressions that are responsible for parsing the various container runtimes, and some also additional parsing to extract Kubernetes metadata from the file path, which looks a bit scary, it's a bit complicated, and if somebody wants to actually interact with it, need to be really familiar with this concept of file log operators. Fortunately, this can be hidden in the Helm chart behind the preset, which means that as users, we just need to enable the preset, and then the Helm chart, when it is installed, generates this configuration and makes it available to the collector. But again, there is room for improvement there, because we would like to have support for testing this properly, and again, if we want to actually change it or support it in the future, it's quite complicated. So the question is if we can do something better here and simplify this, and the answer is yes. That's why we decided to introduce this new parser of the file log receiver in order to encapsulate this whole logic into one single component. And we came up with something like this. It's configured like this. We introduced the container parser, which can be enabled in the configuration. That configuration is the equivalent of what we saw before, the very extensive one. So it's quite simplified, and everything happens automatically by this parser because the whole logic is encapsulated there. And having a log line like this in Docker runtime, which is written in this specific file path directory, we can produce log entries that look like this, where we have the body stored properly, we have additional attributes from the tags, and we also have additional resource attributes, which are Kubernetes metadata, which are really useful to troubleshoot our applications. And yeah, additionally, this parser can also support, can recombine messages logs that span across multiple log lines, which means that in the CRI format, we have this option to write partial logs, and we can understand this by the tag, either it is P or F. So this parser can also recombine these kind of logs and produce one single entry in the end, which is really useful. And this is one specific implementation detail that led us to implement this as a file log receiver operator instead of having it as a standalone processor for the collector, because in the processors, we cannot guarantee the orders that the logs arrive. So in that case, we won't be able to recombine them properly. like to support this specific use case. So we see that file log receiver is quite useful. One question here is how we can further enrich these logs with additional signal information like context-specific information like traces, trace ID, span ID, and so on. The answer is that file log receiver cannot do much here unless this information is part of the message. But again, we need to define additional parsing patterns, let's say, to extract this information. So there is an alternative here. If we have access to instrument our applications, we can use the SDKs, the OpenTelemetry SDKs, to instrument our application and start capturing their logs and emitting really nicely structured logs that follow the OpenTelemetry log data model. And we can produce records that are really enriched with all these additional information that are coming from the specific context, like traces, the process that is producing this telemetry, and so on. But this comes with some drawbacks. For example, this adds extra overhead because the applications are responsible for exporting the logs over the network. And in some cases, we have seen that it can produce log duplication because we have the SDK capturing the logs and sending them to a remote. And at the same time, if you're running a file log receiver on the cluster, it will start capturing the logs as the library writes them down to the file. And you can handle this, but it's not quite optimal. So in that case, we can combine these two different solutions. We can configure our SDKs to use the standard output log exporter, which means that the OpenTelemetry records are serialized into JSON. We call it OTLP JSON, and are written down to the console, and then the container runtime writes them down to a file into the var log pods directory. Then if we have a collector and the file log receiver enabled, we can start collecting these log lines there. What we will find looks like this. We see that we have a very big message here, and we can spot that we see the container runtime format being present in the beginning with the timestamp, the specific tags. Then we have something that the SDK adds. In this example, the Java SDK adds some information about the logging class. And the important piece here, the important part, is the OTLP JSON. This JSON content here is a valid OTLP record, the valid OTLP log that the SDK produces. So we can understand that if we have a way to get rid of the additional information and deserialize this OTLP JSON, we have back the valid OTLP record that the SDK produces, and we can further process it or deal with it as we want. So we can do it. We can use the file log receiver again to properly unwrap the container runtime format. Then we can process this entry with a transform processor to remove the Java SDK class information. Then we can move the OTLP JSON part to an OTLP JSON connector, and this connector will deserialize this JSON and will produce a valid OTLP log record. And after this point, we can just we can export the log record, or we can further process it into the collector. And this is how the configuration looks like in a simplified way, a simplified version. We have the file log receiver and the container parser. We have the transform processor. Then we have the OTLP JSON connector here. And in the end, the OTLP JSON connector can send the data to an OTLP exporter, for example, and send these records to, we can send these records to an observability backend, for example. And I don't know, yeah, it's a bit small, but this is what the collector will produce in the end if we configure the collector to export the data to the console. Here we see a log record, which is exactly what the protocol defines. And we have all these resource attributes here defined, information about the specific process that produces these logs. On the bottom, we have the trace ID and the span ID information, which help us understand the context that this log record was produced by. And also we have the log message here in the body. And this is exactly the record that the SDK produced. And it was serialized into JSON, written to the console, down to a file, and then the file log receiver collects that and deserializes it back and produces this valid record. which is really useful because it solves these two problems that we mentioned before, the log duplication and the extra overhead that we add on our application when we send these records over the network. So to recap this, we saw how we can use the ecosystem, the OpenTelemetry, to collect logs from containers on Kubernetes clusters by using the collector to collect directly the logs from the disk, or using the SDKs. We saw the trade-offs that each option has, and we saw how we can combine these two solutions in order to get the most out of them. So now let's have a quick demo to illustrate this idea. And yeah, for this demo I have a GK cluster with 3 nodes, and I'm going to install the OpenTelemetry demo. The OpenTelemetry demo is a sample application that consists of multiple microservices, and these microservices are instrumented using the OpenTelemetry SDKs. So I'm installing the demo now, and at the same time I'm going to install the collector as a daemon set in order to start collecting the logs from the files on the disk. So let me install the collector. I'm also going to install a sample application, a daemon set that writes logs to the console. And this is not instrumented, just sends the logs to the console. So here I can see that the OpenTelemetry demo is running. The pods are getting started. This is the daemon set, the collector daemon set that collects the logs from the files on the disk. This is the sample application, and all these applications are the microservices that the demo runs. Let's also forward the port of the demo, and let's go back to the page to produce some traffic here. Let's check some products to have some logs written. And so now we are interested about this specific microservice here. It's a Java application that is instrumented, and I have configured it to do exactly what we described before, which means that the SDK writes the OpenTelemetry records to the console, and then these logs are written down to the disk. So let's let's check what the logs of this application look like here. So here we can see that we have this exactly that we described before. We can see the Java specific content here in the beginning, and then the rest is the OTLP JSON part, which we are interested into. Now, if we check also where this application is running code, we can SSH on this specific node and check what is stored on the disk, so as to completely understand what is going on here. So as users, we don't need to do it. We are just exploring the solution here now. So this is the directory that the application logs are written from the containers, and let's see. This is the file that the container logs are written, and let's see its content. Again, we see what we saw before in the console, and we can spot here that we have the container format adding the container runtime adding additional information. That's exactly what we need to parse. We have the file log receiver to parse it, remove this unnecessary information, and properly deserialize this OTLP JSON record here. Let's get back to the Kubernetes environment, and let's find again where this application is running. And okay, let's find the specific collector from the daemon set that will be collecting these logs, and let's look what this collector is doing. It's this one. So here I have configured the collector to send the data to a remote, to an observability backend, but at the same time to export them to the console for debugging reasons. So here we can check exactly, we can see exactly the OTLP records that the collector is producing, And this is exactly what the SDK writes. So we see that the SDK produces these records. These records make it to the file on the disk. The collector collects them and properly deserialize them. And we have exactly the same result here. And if I go to a backend, I can also see that the records make it here. So here I have the add service again, and here are the records. This is the message of the log. These are the resource attributes. And if I specifically look for specific information, I can see, for example, the trace ID here, which means that I can further correlate this log with other signals. And I have information about the process that generates these logs, cloud metadata, and so on. Compared to the very raw application that is not instrumented, that again, the file log receiver collects its logs, but then we don't have very rich metadata here. I don't have, for example, the trace ID or the span ID because the application is not instrumented. Still, we can find some metadata that the collector adds, but it's not so enriched as the previous one. And yeah, I think that's all about the demo. Okay, we still have some time. So let's get back to the presentation and wrap this up. So yeah, some next steps here in these features. We're considering of adding support for additional formats like the Klog structured logging format that the Klog library of Kubernetes produce, which is used by the control plane components of Kubernetes and other kind of Kubernetes-specific applications like operators that could be useful to support this as well. We're also working on providing better user experience in this feature, which means that the collector will be able to automatically enable the log collection based on hints that are provided as pod annotations, which means that I can annotate my pod with specific tags, and then the collector will understand how to parse it and so on. And last but not least, we would like to have support for more well-known formats from well-known technologies and have a way to package them better so as to provide the option to our users to, instead of rewriting configurations, OpenTelemetry collector configurations, to use them out of the box. And you can find some related issues here in the presentation later. And if you're interested, you can follow them. And yeah, with that, I think we are top of the time. So yeah, thank you very much. And any questions? Yep.
Is there a reason for logging everything to disk first rather than using like syslog or journald to capture everything?
In this specific, yeah, you can also have different architectures. In the presentation, we deal with the most famous one, which is the one that I shared from the Kubernetes documentation, where the containers write the logs to the console, the most simple one, and then the runtime writes down to the disk. You can, of course, have different architectures, but that requires extra tuning. This is the most simple one, and it's the more generic one that we have seen out there that users use.
And do they have documentation to avoid things like the ingress controller access log flooding the disk or anything like that?
On the collector side, we don't deal with this specifically, but yeah, again, it depends on the use case. You can deal with it. It's another story, I think, what you are describing. So yeah, we don't include this in the documentation.
Thank you.
Any other questions?
One.
Are there any plans on converting the stanza operators to hotel processors?
So yeah, one detail here is that file log receiver was produced by the donation of the stanza agent or library of ObserveIQ. So under the hood, the file log receiver runs the stanza receiver. And these operators are stanza operators, actually. That's a big discussion that is taking place. I don't know if this will happen eventually. Some limitations, for example, when you are deciding to use a processor, the way that the whole pipeline, the whole collector pipeline works cannot guarantee the order, for example. So in this specific case, if we were to implement this as a standalone processor of the collector, we cannot guarantee the order. So we lose the order, we cannot recombine the message. That's why we decide to do the extra processing at first place in the receiver.
All right, this time I'll look behind me and see if there are any questions there. Nope, no questions. Well, thank you.
Thank you.
We'll have our next talk at 5 minutes after the hour.
Yes, yeah, so we don't get the feedback loop.
Should I take care of it?
Yep, testing. Hey, it's working. Technology.
Yep. It's gonna be weird because I'm selling the whole cube out.
So, yeah. Do you remember how to enable this phone screen? What? Range or? Plenty of time. Should I dance? Some stand up? Dance like no one is watching. Yes. You see? You see?
Yes, we will. No, we won't.
Not the elephants, no?
I thought we would. You see, PostgreSQL shirts are the best. Every single time.
Yes, if you guys are into animated elephants and dolphins, you will have a little bit of fun today.
Yeah. You may notice, when I'm not covering the screen, that we've added a word to the title, just to make sure that everybody understands that we are going to be talking about database deployment, not a particular construct in Kubernetes in deployment. As we proceed, my name is Jan Wieremiewicz, and I'm a product manager in Percona responsible for PostgreSQL.
And my name is Piotr Szczepaniak, very hard name to pronounce, I know. And I'm a product manager responsible for Percona Everest, which we will also show a little bit today.
Yes. If you don't know Percona, we've been out there for about 20 years, and we have been always true to open source. Our main value is to provide free and open software to everyone, so there is no not free software that we provide. All of our software is made so that our users can become our customers, can grow into wanting our support and consulting services. So we actually do want to make sure that entrepreneurship happens and it actually is successful. And when it is successful, we can help them scale further with the best experts out there. So this has been true for almost 20 years now. We started with MySQL, adding other databases like PostgreSQL, MongoDB, and Valky now. And we have other products, and we want to show you why and what we did and how it can help you in your everyday life. So,
Right. Viewer discretion is advised. As I mentioned, there is a rumor that the local governments are actually thinking about creating a special rule for a limited amount of AI-generated images you can use in a single presentation. This man is crazy.
I'm guilty as charged. I have to admit that it has been a struggle for my whole professional life to prepare public presentations because of the fear that I'm going to infringe on some copyright. Thank you, AI. So until this is settled, I'm gathering a library of as many images that governments have not yet put any copyrights on, and I will be using them in the future. So my folder is around is measured in thousands of AI generated images I can use in presentations already. So VP prepared. Yeah, that's what
Hopefully we'll have some fun with this.
yes.
Right.
So I will ask you basically about cloud managed databases, because we do see a lot of usage over the last decades of cloud managed databases, and I would say that there are some pains about them. Our wallet is one of the main pains about cloud managed databases, as I like to say. We see some of the known millionaires flying to space with the money that they're taking from us, from our cloud managed databases. What are the other pains that you see?
Right. So, like Jan mentioned, over the past 10 years, we all know RDS. Everybody heard about Atlas. I think we all, or Aurora, or other public managed database as a service. They all bring a lot of benefits. We will talk about them, but they also have some limitations. And the limitations, it always depends on what you're actually looking for, what are the challenges you are facing. But while interviewing plenty of public DBAS users over the past 2 years, I kind of listed out a couple ones that are repeating most commonly, like things like security and data privacy. We heard about data leaks and breaches so many times, and it's a little oopsie. It should never happen. Basically, all of the things to make it secure and safe are in place, but there's a human error or whatever else that caused data breaches, and it actually costs company a lot of money. Limited customization, you get a black box, you get what you get. A performance variability, things of a noisy neighbor, right, and many, many more, like compliance challenges, vendor lock-in, or the poor wallet that Jan mentioned.
Yeah, but the fact is that we know that there's a lot of bad things about them, but they're still super popular. And in a way, this kind of shows that this is what we are looking for. So I would like to learn from this. So for this, I would like an exercise. Let's imagine like we are on a mission. And our main mission is actually to deliver the qualities that our users, our business asks from us. And this can be a learning experience, looking at cloud managed DBAS, what our users actually expect. So if this is a mission, let's basically talk about it as a main one that we focus on. And some of the best values that come from Cloud DBAS are here. Peter, can you go over these?
Yes. So why are we liking the public DBASes so much, right? For their scalability up to the moon, flexibility in terms of like elasticity in your configuration, simplified management. You don't need to be a DBA expert to manage RDS. Click through the interface. Everybody can do it. Improved resource utilization, enhanced high availability, disaster recovery, these things are giving us with our operator, as well as cost optimization, especially for the Kubernetes ones.
So for this, I'd like to start with a question. Have any of you played RPG games before? Like a bit out of it, yeah, I see people nodding heads, right? So I started with like a mission. So let's start this game like as we are in a game together. Let's go on an adventure. And to start, we need to define our main mission. In so many games, I've noticed that I'm saving the world, and yet I'm going to kill some spiders and gather some misplaced spots for some granny. And here I see there's a bit of a familiar situation very often, as we are looking for end values for the main goal for us, and yet at the same time we are focusing on some not necessarily most important details that are actually obstacles and not something that we should be looking for. And the second question I would like to ask is, any of you running databases on Kubernetes or are actually planning to do that? I see some hands, less people than people play RPG games. Yes. I see that RPGs are still a better trend to follow. The geek in me is very happy. So I'd like to finish this questioning exercise with an ask. So let's play a game. And in this, I'm going to ask you, how many do you think that I will get? I just went to operator.io and I asked how many PostgreSQL operators can I get. It's very close. So currently on operator hub.io, I will get 11 specifically designed operators to deploy PostgreSQL. Each has its own twists. Each has its own approach to particular lifecycle management operations, and yeah.
Yeah, another challenge with operators is, even if it fits you well today, they are moving so fast and there are so many new popping up. Some of the old ones are dying. Are you sure that the one you're picking today is going to be the best one for you in a year, 2, or 5? Or are you going to have to go through the pain of replacing operator down the line?
You can also see that there's 15 here, right? And not all of them are actually specific ones that you want to deploy for PostgreSQL. So we have to get into the details of everyone. It's not easy. So it kind of makes me feel like we're playing America Got Talent. Like you have to go and look at every single one operator and choose which one is better. Some have downsides, some don't. Yeah, see, I told you this is going to be fun with images. It's like, I really feel I'm living in a meme at times when we are discussing which operator to choose.
Yeah, and that's totally understandable, the meme feeling. It's really not easy to pick the operator. We will dive deeper today on why we think this is not easy. And like I mentioned previously, like, does it mean that it's today this is the good one? Does it mean that tomorrow or in a year it's also going to be the right operator?
So at first glance, this table does not seem intimidating. It doesn't seem super complicated. There are some twists. There are some familiar values, like the same ones. In a way, I don't see how this is so complicated.
Yeah, true. At first glance, it looks simple, easy. Everybody almost supports the same thing. There are just minor details. The moment you start actually implementing those operators and diving deeper into the technical requirements of your setup, your configuration, this is where it all starting to come up when you start learning on a forum. Oh, if you would use X operator, you wouldn't have this issue. They don't mention you have 30 different ones. So we will dive a little bit deeper into one of those elements.
Let's take the first one. Let's take the first one. We have every single one is the same, right?
Yeah.
All of them provide high availability, right?
All of them are HA.
So
but really,
yeah, it seems that the elephant devil is in the details here. It seems that there is actually a different approach to some of them. As I don't know how many of you are PostgreSQL DBAs. PostgreSQL DBAs are familiar with particular solutions to deliver high availability. Patroni, delivered by Zalando, is one of them. It's one of the tools that is known to help with automatic failover. And right now, most of the databases use Patroni. Some, because of the, let's say, the downsides, the deficits of stateful sets, chose to implement their own very successful tools to do that. Though a DBA familiar with patroning, having to learn Kubernetes, now discovers that adopting the cloud native PG operator, they would have to lean on another unfamiliar technology, being the re-implemented way of handling high availability. That's not an easy thing. We're talking about the total change of thinking in the known patterns and in a very critical value, which is high availability.
Right, it's become a nightmare in scale. We analyze so far HA only, but there's a lot more. So when you look into every database lifecycle aspect, it turns out that there's a different approach everywhere. It simply is a nightmare. Freddy Krueger.
So, okay, I totally get it, especially when you look at those numbers. And do you dare to guess what these numbers are?
Yeah, all of these are the number of versions we have seen from the most popular operators. These are not all the operators, because not all the open source operators are publicly sharing information about the versions. But yeah, this is like in 2023, we had 86 new operator version, 2024, 75 so far, and still counting. And you need to keep up with this.
They change from version to version, and what you came to understand today is going to be something different in a week. It's really hard, and there is not a tool that provides you a simple understanding what are the values that just came in with the last deployment, with the last update of their operator. And while we focus on these numbers and complexities, the world did not stop spinning. The expectations from our users and from business keep on growing. Our business is usually way further than we are in expecting what they want from us. But let's not dig into this as much as into our teams, like into DBAs, into SREs and DevOps, who know about the ease of use that could be there, yet they have to focus on those small little details to deliver to deliver the capabilities. And to sum it up, what is the magic sauce here that users are looking for? The managed databases are great, but hard to achieve in Kubernetes?
Right, so what we're essentially looking for is a reliable, cost-effective database deployment that has a user-friendly interface that our users can interface, so we can maybe shift the responsibility left, as everybody is right now looking into, right? And it looks like we have all the building blocks needed to create it, just need to connect them somehow.
So data on Kubernetes is the answer, right? Containers are there to provide exactly what you're asking for.
Yes, Kubernetes scales up and down automatically based on the demand and has built-in solutions that help with high availability that we all know and love in Kubernetes.
And we have open source to lean on as well, like Kubernetes and PostgreSQL, because we chose this particular database to talk about, are both open source. It seems that there's also great benefits coming with that.
Yep, there are also opportunities to be free from vendor lock-in. There are plenty of open source solutions that you can keep, that allows you to use and will help you being free from that nasty vendor lock-in.
So unfortunately, the benefits come with downsides as well. We have seen how long it took for Kubernetes to deliver persistent storage scaling, handling in a way that can be appreciated by the database providers. It's been a while, and I believe that there are way more other lifecycle operations that databases need from day to day to make the day two handled by operator in a way that we should expect, I believe.
Right, and it would be nice if you could get rid of all of those downsides, right, that we see here.
But so are you saying that?
Yeah, what if we could stop wondering whether your particular operator uses stateful set or something else, stop focusing on the details, and came back to our main mission? What was our main mission? We want to deploy our database, right? It's not about the operator.
So not focusing about whether we use stateful sets or not, but focusing on having the best of the two worlds in terms of experience, in terms of what our users are looking for. So what if we go back to this main quest and...
Yes, so we're all talking about Postgres all the time, but it's not only Postgres, right? There are other databases. And what if we can make this solution not on Postgres only dedicated, but have it actually multi-database? I knew you're going to love this picture. There's so much happening here.
I still don't understand why the turtle, though, but I'm fine.
Right, so please welcome to the stage our latest and greatest Percona Everest. And maybe real quickly, why we as Percona started investing in building. So as we mentioned at the beginning, Percona, every software we create is fully open source, Apache 2 license. So why we even decided to start investing, and we're investing for the past 3 years into Percona Everest. What we noticed immediately when we started releasing operators is operators are great. People who know Kubernetes are really happy and can use them very efficiently. What about the peeps who are not very familiar with Kubernetes? In order to use operator, you need to create a custom resource file. You need to understand how Kubernetes will reconcile and create and deploy. And these are not things that developers that we're trying to shift it left to are actually thinking of and focusing on. And what we notice, there is a huge adoption barrier for operators. Mainly, hey, it's great, we love it, but we try to onboard the rest of the team to the operator, and they pushed back. So we decided to stay on the public DBAS.
It's hard to convince somebody who's used to controlling their database through UI, as in RDS, to now go back to like 5 steps back and think about all their little knobs that they have to turn in, well, usually in the text format, actually. So that's why we like graphics, right? So let's dig into what has been delivered so far, and Everest. Let's just have a glance at what's available already for you if you go ahead and try it.
Yep, and I'm going to be very quick with this. What if we could deploy our database through the UI? What if we could design a replica set also through the UI? Define affinity configuration. What if we could create backup policies? And so the way they match our internal policies. What if we could just sit back and see how the operators do all the heavy lifting for us? This is the reason why we decided to create Percona Everest. And of course, all the day 2 operations are also in there.
So right now, what we are facing with Everest is we are working to deliver it to the scale that you can use it on production for all of your databases. But we're looking for your feedback and what's next was blocking you to do that. We believe that it's already there, but maybe for your particular organization, there is a particular RBAC feature, or roles and management, that you are missing to do that. And definitely, this is something we are looking for feedback on. The main problem in doing stuff open source is that while it's available to everyone, people getting stuff for free don't always feel entitled to asking for more. So we are in product development, and we need feedback about, yes, this is great, but this is missing. Oh, this is great, do more like this. This is the feedback we're looking for. Patting on the back that something is working. Woo. And actually sharing the drawbacks that we could make it better. And actually, this is open source, so if you feel that you're on the code level that you could contribute, that's totally fine. But contribution does not have to be code. Contribution can be also feedback. This is the big gap that we fail to remember, that sharing with somebody that we like it, starting the GitHub project is already something like that lets us know that you like it. Being active on the forum, commenting the blog post, it's something that tells us, yes, this is what you want to see. Or maybe saying, yeah, this is boring, you've already written that like 2 months ago, can you do some more? That's also important. We should focus, like this is the main reason, like the main goal of product management. Do the right things, not do the things right, but do the right things. We want to do the right things at the right time. Maybe we are focusing on something right now, delivering value in a place that you say, yeah, but we cannot use that until you do the other thing. So please do try it, and please do share feedback with us.
Yes, we product manager, we love feedback, so it's basically everything.
So lastly, this is the moment where questions start. Before we start the question, whether all databases should run on Kubernetes, because we get it a lot, I will simply answer no. Like so let's not go into this rabbit hole, because I understand that maybe sometime in the far away galaxy, yeah, sure. For now, the big monolith databases, we don't see that happening. But if you want to get into those rabbit hole questions, please visit our booth on KubeCon. We have great T-shirts to people who participate in Everest demo as well. And we're ready for your questions right now. We have one more slide in the end, maybe. Let's go to the next slide and do the questions here. So that while the questions are being asked, you can also scan the code. And look, Everest, this is a walking mountain. Like, how can you not love this?
I love the UI that it makes it easy for people to create and also inspect. That part is open source.
Yes.
And the second question is, would that UI be possible to be integrated in something like Backstage if it's written in
Yes.
in
So
TypeScript,
right.
TypeScript and React.js, I think it is?
So the way Everest works is you deploy Everest into a Kubernetes cluster. It's got its own operator. We deploy our own pods with our API, backend, and frontend. So everything is self-hosted. You basically deploy it wherever you want. And you can connect it through the API. You don't need to use the UI. You can connect it through our typical REST API and integrate it with any platform. Actually, a lot of usage that we are seeing are platform engineering teams that build the whole internal platform so the developers can self-provision, self-install, self-manage, and they use Everest as the database piece because it basically provides everything built in. But they don't use our UI directly.
I heard something in between the lines, so I have to comment on this as well. So we provide free and open source software, period. There's no non-open source software from us. Everything is open source. We believe that if you have non-open source software, you will make somebody use it in the end. This is how it works. You've heard MongoDB CEO saying that open source for them is adoption technique. So this is basically open up the funnel and getting somebody into the proprietary software. We don't have non-open source. We do not monetize our software. We want you to be successful with using Everest and say, Jan, we love your software. We would like our staff not to focus on the simplest use cases that our teams come to us with support. So can you handle our support? Can you help us make our deployment better? And here we kick in with the best experts helping you with support or with consulting.
Really cool. How do you see this compared to things like Crossplane or other CNCF projects that are kind of also focused on helping deploy databases and kind of platformize the whole thing?
It's a little bit similar like with the operators. Yes, there are platforms that are filling the same gaps. And when we started 3 years ago, it was a completely green field. There was absolutely nothing on the market. So I recently seen, I think it was a product was called CubeBlocks as well that has a similar approach, but I believe their UI is proprietary. But it is similar. They can fill each other gaps somehow. I think Crossplane was it Postgres only, or was it multi-database as well? Oh, right. Right. So again, there are multiple solutions that are solving the deployment issue, and even the operators. Like you get a CR example, you put it in your CI/CD, and you can forget about it most of the cases, right? It actually really boils down into those day two operations. Can I give my developers access so they can just restore the database themselves? I don't need to bother with this. Or they need to scale it up? Fine, just scale it up. There's your environment. Do whatever you want.
And again, I will add here that typically, when you build a product that you want to be open core in any product, you want the developers to adopt it easily. This is the part that's open source. You monetize the day two. This is because if developers deploy the developer product based on your open source software, and in the end the business gets it, and here they day two operations, they will have to pay for the license to use the open core. This is very often with a lot of products like this. Unfortunately, this is the issue. You get an easy open source deployment, and very often you don't get all the gimmicks that are needed during day two. You have to pay for them. Like this is monetizing of the source code. It seems open source, it isn't.
It happens very often that you build a POC with open source, and then you want to move from POC to an actual solution, and you're realizing that some of the enterprise features that you need are hidden behind a gate of, oh, for this you need a license, oh, for this you need this and that. So this is what we as Percona were trying to push the message that everything should be open source.
Sorry, I think there's also some.
Just a quick question. Is this available on RTC?
Not yet. ARM64 is actually on our roadmap. So making Everest and operators ARM64 is actually quite easy. What we're waiting on is our pillars. So our database distribution for MySQL, Postgres, and Mongo.
PostgreSQL is ready.
Yes, we're waiting, I think mostly for MySQL, to be honest. Yeah, Everest itself, so again, we will make Everest ARM ready within like 2 weeks within one release, the moment we have all our database engines ARM ready. And then making operators and Everest operator ARM ready, this isn't an issue.
Would that be limiting to you, not having it on ARM currently?
Mm-hmm. Yeah, we see a great growth of ARM architecture.
Thanks, Mary, for the talk. I was just wondering, is the UI limiting in any way to the toggles that you can pull in the YAML definition file?
Right. So currently, yes. Like I said, we started working. The idea of Everest started about 3 years ago, but we started working on Everest actually a year and a half ago. So we are still catching up to multiple of the operator features. Operators are on the market for 3 years. They built very in-depth functionalities. What is really cool about this is if you cannot set it in Everest, you can tweak it in the operator right now. So there is this flexibility that you can still adjust. Our goal eventually is to get to the feature parity. Everything you can do in operator, you can also do in Everest through UI. But again, like challenges, we recently, the last feature we're working on is affinity configuration. What is affinity configuration for an operator deployment? Well, you define your affinity rules in your CR file and it's done. If you want to use it through UI and walk a user who doesn't know what Kubernetes is and doesn't understand the affinity, these are the challenges that we are facing building this UI. What we spend a lot of time as well is we're kind of pushing into the product. I call it codified Percona expertise. Over 20 years of building databases and managing databases, we learned a lot. So we're pushing a lot of this knowledge into our software.
Last question.
So let's say I use Everest to install and use the databases, but I have another software to manage the database.
Mm-hmm.
So does Everest expose any APIs, let's say, that can be leveraged by the data management software to back up, restore, and migrate the database?
Everest itself not, but the database engines are.
Everest is the API first as well.
Yeah. We are. But if you want to use a different tool for backupping, for example, for MySQL, we're using Percona Extra Backup. If you want to use a different backup tool for MySQL, you would have to connect directly to the database, not through the even operator.
So if I understood correctly, the connection URL of the database would be used to just take, let's say, logical backup or something.
Yep.
Cool, thanks.
Mm-hmm. Yes.
Multi-cluster is...
Multi-cluster is actually on our roadmap. We're going to start working on a POC in Q1 next year. So right now, Everest instances is single Kubernetes. You want to, exactly, per cluster. But we are considering having multi-cluster support. So you will install the main Everest in a single cluster. It can be even without any database permissions and whatever, and it would manage multiple different Kubernetes clusters.
Look at me now being like not the best buddy. Like you should do multi-cloud, multi-cluster, right? this is what users are looking for.
Clouds are actually agnostic to us. As long as the Kubernetes flavor is vanilla-ish, yes. Right.
Can you repeat the question so that
Right. So the question is about Argo CD and Flux. Right now, in end of November release, we will release Helm charts. Helm charts will allow you to integrate with Argo CD and Flux. Oh, so you're afraid of reconciling it back again to the same stage? To be honest, I don't know the details. I would have to check. I know Argo CD is actually one of our top use case that we want to support with Helm. I would have to figure out how our technical team actually figured this out. We can connect later, or you can visit our booth, and I'll get this.
Seems like a great booth conversation.
Yes. We're out of time.
Well, Peter, Jan, thank you, and your AI elephants and dolphins. It was great. We're going to take a break. We'll be back in 5 minutes with our next session.
Thank you.
Thank you, guys.
Take it away, Ram.
Thanks, Sean. Hello, everybody. I'm glad you could find your way to the flex space at the venue. It wasn't easy for me the first time. But anyhow, welcome to my session about Wasm and Unikernels, two technologies that I kind of stumbled upon. And for the next 20 odd minutes, I'm just going to talk about what seemed like a great idea at first. It continues to seem like a great idea, but it seems like a great idea for a variety of reasons. And I just thought I'll go into some details about why that is and what I discovered was good about the two technologies and things like that. But the story of how I found my way to this talk was, fortunately for me, my job allows me to sit down and think kind of like a theoretical physicist. And then it allows me to sit and design certain experiments to find out what these technologies can do. And the engineer in me obviously is quite capable of figuring out ways to hack some code together, and ding, 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 I am Indian. So I have the Big Bang Theory bingo, and that's sort of how I chanced upon this talk. And so a little bit about Wasm for those who probably don't know about it. I don't think there are too many people in Salt Lake City for this conference who don't know about it. But for anybody who's not aware of that, Wasm is designed as a binary instruction format, which means that it is capable of running a very standard set of instructions, irrespective of what language or framework you write code in. So it sort of started off as a way to mimic JavaScript in browsers, and it's found its way to doing a lot more than just that. So there's obviously Wasm that can do a lot of languages and runtimes in the browser, but today there's also like server-side Wasm, which is doing a lot more than just replicating the success of these interpreters in the browser on the server side for various reasons. Now, what makes it particularly useful is, like obviously the ability to run code written in any language or framework inside the browser, but also like use these Wasm-based compilations of any language or runtime and make the characteristics of speed and other things available, irrespective of whether you run it on the browser or whether you run it on the server side. Now, Wasm has a little bit of a love-hate relationship with the way it manages memory and things like that, largely because it carries its concepts of working in the browser to working in the server. But the community, the amazing Wasm community, is making a lot of strides in solving a lot of these problems and removing a lot of the kinks that make it suited just for browser versus making it more general purpose vis-a-vis doing like browser-based stuff versus server-based stuff. But I've touched upon a little bit of what makes Wasm useful, but let's examine it from one or two very specific aspects. So there's portability, which like I mentioned, this whole holy grail that we as engineers have had for as long as I remember, the right ones run anywhere kind of paradigm, which we loved Java for that, and we chased it with like a Java hat, and then we looked at so many other ways of doing this right ones run everywhere or run anywhere kind of thing. We continue to do it with containers. We continue to do it with something new that we find, and Wasm sort of lives up to that promise a little bit, and so we continue to chase that dream with Wasm. There is this thing about wanting to run things fast and faster and the fastest way possible. There's only so much speed can do, but Wasm promises to deliver a lot in terms of speed, because just the way stuff written in assembly language runs fastest on hardware, Wasm aims to replicate that kind of performance using all of the different components and other, its architecture oriented towards providing that kind of native, or what they like to call near native performance. We'll do a little bit of a deeper dive as we go along. And like a good developer, I put security last, but Wasm does promise a lot in terms of how secure it can make code and how secure it can make application runtimes. The reason is it works in a sandboxed environment, so there's very limited access that Wasm applications have to the artifacts that are underneath it, and so it's very convenient in terms of what it can do for security. And the other half of this talk is about unikernels, and I found that a lot less people have heard about unikernels itself, but those who have are very opinionated about how useful it is, or how useless it is. So unikernels, much like a lot of the different technologies that we know, has been around for a long time. So when I was researching for this talk, I was looking at like unikernels, and going back in time, there's something that there's a surge of articles about 6 or 8 months ago, and then the search before that was like 2 years ago, and then I found something for 6 years ago, and I found something for 9 years ago, and every one of these had like a recurring theme. So somebody came and said, hey, Unikernel is the next big thing, and then around the same time period, somebody said Unikernels are dead, and then 6 years later, are Unikernels really dead? And then Unikernels are going to become the next big thing. And so there's a theme here, I guess, but I don't think Unikernels' container moment has arrived. For like anybody who's familiar with containers knows that the technology has existed, but it just found a developer experience around it about 10 years ago, 12 years ago, and changed the world as we know it, right? So maybe Unikernels' moment hasn't arrived, but what it is basically stripping down stuff that you don't need as part of a base operating system and narrowing it down just to the kernel that you need with some of the libraries and other things, and creating some virtualization that can interpret this combination of application code tightly coupled with the kernel. Now, this is, in order to just visualize this better, this is what regular virtual machines look like, the stuff that we overpay for. Now, obviously, we don't run just one application. We run a whole bunch of different applications right next to each other. And in the case of Unikernels, it just takes this OS block and almost eliminates it completely and couples the application and the kernel a little closer. And what that looks like in reality is it basically shrinks down into something much smaller. So what this can do is, for the same amount of infrastructure that you pay for, you can pack a lot more in terms of applications on a single unit of compute. So you can have denser compute, you can have cheaper compute at the end of the day, and things like that. But obviously it comes with a little bit of a trade-off, which we'll talk about later, and not talk about the negatives right away. What makes Unikernels useful? The same thing. So it's always better performance, more portability. It's a smaller unit that you can just shop around. Maybe this is people's answer to write once, run anywhere. So it's always chasing these goals of portability and performance and security at the end, right? And so that led me to sort of start tinkering around and looking for ways in which, hey, because they both share a lot in terms of the narrative itself for what they're trying to accomplish, is there a way to make use of both of them together? So is there a way to say, hey, let's do Wasms and Unikernels together, and what happens if you try? So let's jump a little deeper and understand these three vertices of portability, performance, and security, and see if there's something that we can win. Now, what I want everybody to remember is Wasm and Unikernels approach the same sort of promise, but from very different angles. So Wasm takes an application first approach and focuses on an app developer sort of persona, and then the Unikernel sort of comes from the other end, where they're focusing on what they can jettison from like the bulky operating system and things like that. And so it's more for suitable for ops folks that are trying to minimize things at that level. In terms of portability, both of them compile into binaries, but the way Unikernels do it is they do a very platform specific version for an application that you're trying to run. So given your application and given your platform, you're able to spin up an image called a Unikernel essentially. You're going to be able to spin up an image that will run for that specific combination of application plus infrastructure. Now Wasm, on the other hand, compiles into what is known as a Wasm format. Now that Wasm format can then run on any infrastructure that basically exists. So this is the internal of what that Unikernel looks like. And so if you compare like block diagrams, which everybody is so amazing at, you can see where the difference lies and where the architecture provides the bulk to disappear essentially. So the OS plus kernel is the bulk of what we have to operate, and then by eliminating the non-essential parts of the operating system, you basically provide you provide the kernel to the app, but you also provide like very small overhead in terms of the operating system itself, and that's what makes a Unikernel tiny, but continues to keep it useful. And Wasm has a system where they have a different compiler for each different language or family, and through that they're able to generate a binary format that we spoke about, and there's like a Wasm virtual machine. And so the idea here is you take that Wasm binary format, slap it on top of this Unikernel and generate one single image, and that way you can gain the performance benefits of Unikernels. And what that results in is something that can cold boot in milliseconds, as far as all these commercial Unikernel providers advertise it. Wasm itself as a runtime is extremely fast, so you now can boot very quickly and run very quickly, and so that's what these two layers sort of bring. So like I said, they approach the same problem but from diametrically opposite ends, and that in theory makes it very useful. And I'm going to keep saying in theory. I don't want anybody to sue me, because I've tried this. I'm yet to realize the full benefits of that kind of the kind of performance that they promise, but it works, and we can take a look at how towards the end. The second thing I wanted to talk about was in terms of performance. So like we've been speaking about, the speed comes from two very distinct areas, and there's a bunch of benchmarks that the Unikernel community has. So if you're too lazy to type Unikernel performance in your browsers for a search, just scan this QR code and it'll take you to showcase a bunch of different experiments that have been performed around how you can basically benchmark different applications depending on the context, and understand where these 2-3 different paradigms of making things faster arise from. So here there's like the orange bar is what is the default configuration. The green bar next to it is takes into account what is known as link time optimization, and then the blue bar next to it is for dead code elimination, and then the purple bar at the end is where you combine these two techniques and realize the full potential of the technology. So this is a bunch of different benchmarks advertised by the Unikernels community, and this is just borrowed from their documentation page for, again, this is the case of different Unikernels that are now available. I'm sorry, I should have mentioned that before, but there's like a bunch of different communities working on different kinds of Unikernels, and so one of the most popular ones is Unicraft, and there's also a Nanos Unikernel community. Hermitux is a Unikernel community from the Rust folks. Complicated as shit, but still good and demonstrates a lot of the capability quite well. Rampran, that's towards the end here, was quite popular a little while ago. Same for Mirage and Lupine. It saw a lot of popularity a few years ago, but I'm not hearing a lot about it more recently. This is for a comparative start time or a boot time for running in different VM managers. So Firecracker is obviously like one of the poster boys right now, but it's able to help realize a lot of the benefits that Unikernels can give, and it's not a Firecrackers versus Unikernels kind of situation. So if you're happy using Firecracker and you have the ability to try it, then you can still try Unikernels on Firecracker and derive some of that extra few milliseconds that you might or might not need. This is again memory requirements. There's also stuff about throughput that is on the documentation there. and you can take a look at that. This is a QR for a repo that does Wasm-based benchmarking. I know this is like extremely tiny to see, but this is a sample run from when I quickly ran some benchmarks, and suffice it to say that in a couple of cases, I think 2 out of 5, WebAssembly ran a few programs faster than native or near native architectures that were available. So this is the best example of a benchmark I had for Wasm, but I think there's like a ton of benchmarks that you can get from the open internet, so I'm not going to repeat that here. So finally, the third aspect in terms of security, because unikernels jettison a lot of the actual operating system, the image that it results in contains very less in terms of just code, and so the attack surface is very minimal. So that's their best security position. Hey, we're extremely tiny, and so the attack surface is tiny, and so we are quite secure. So which, depending on your specific needs or requirement, might or might not be a great win, but it's their best position for how they can support secure practices. But the one that I favor more is in terms of just isolating an application. I think they do a much better job of isolating individual applications and their runtimes because of the way they couple the application and the kernel, and so the space in which they operate, the user space in which they operate, the access to like the rings for security and things like that is extremely restricted, and so it makes it a much better system to have isolated applications running next to each other. In terms of Wasm security, the idea or the core ethos for security within the Wasm community is to give developers sufficient primitives and protect these workloads, but keep all sort of malicious modules that might make their way in more visible to users as they're consuming them and things like that. Like I said, Wasm's biggest security feature is their sandbox, and they make sure that stuff that's run inside their sandbox has a sufficient amount of like memory safety and other things. Now, the biggest complaint about Wasm that I have seen, and this is browser-based Wasm, not server-side Wasm, is that when you load a Wasm module that you want to run, there's no native or automatic way to do integrity checks. So because you're transferring a binary from one space to another, the ability to do some kind of integrity checks in terms of like a checksum or something in the form of attestations and things like that in future would be extremely good to have, and lack of that is a big challenge. Now, pardon the self-promotion, but if you're interested in sort of Wasm security, or if you're interested in Wasm at all, there is actually a Wasm.con happening. Don't leave right away. But there's a security in Wasm panel that I'm hosting tomorrow with a bunch of different Wasm contributors. So if security in Wasm is your thing and you'd like to understand that better, I'm happy to see you in the panel. Now, the things I want to focus about further in this talk are why I began this pursuit of trying to make unikernels and Wasm work together. So there's going to be a bunch of cliches, but I'll tell you right away. It's developer experience, it's cost savings, and all of these things that you've heard about so many times before. But like I said, they solve the same problem from very complementary angles, and so it makes a great fit in terms of trying to gain the best of both worlds, and just looking at what kind of what if you divide these three, performance, portability, and security, and then you want to do it at the application level and at the infrastructure level. At the moment, a combination of Wasm and Unikernels seems like the best bet. And a good example of how improved developer experience can be in the Wasm ecosystem is with Spin. So I saw a demo of Spin at KubeCon in Paris on the keynote stage. It was amazing. It's really something, you know, like every developer tool could aspire for, but it's also like this fantastic way of running a Wasm module on your infrastructure. Plus, the docs are never wrong. So if anybody from the Spin community is watching, you know, bravo for your documentation. And that brings me to, you know, talking about some of the downsides here, which is that unikernels, because of their nature of being very tightly coupled to the application as well as the hardware that's trying to run it, don't have a very straightforward path towards being generated as an image. So if you want to generate a unikernel image, you need to have awareness both from the application side as well as the infrastructure side. And so I think there's a bunch that you could do in terms of creating a better developer experience around that. And obviously the community is, you know, hard at work. There's a bunch of different commercial entities who specialize in unikernels who do a lot of this work. And there's also the opinionated ways of the Wasm world that make this slightly complicated and not too easy to achieve. It's a little bit also about how you need to think in terms of a Wasm application and how you need to structure the way you port your binaries. And so the fact that there's two sort of personas at play here, you know, kind of complicates things. There is the application developer whose, you know, sole focus, as we've heard so many times, is on developing the application and not necessarily on packaging it or securing it and things like that. And then there's the ops persona whose usual, you know, job is to provide that infrastructure that I alluded to. And in this case, you know, that's the person who will probably be responsible for the unikernel development. And so both of these have to sort of come together. And you know, the app developers have to focus a little bit on, you know, getting their applications suitable to be built as a unikernel, whereas the unikernel developers have the bigger job of making sure that, you know, the unikernels they're designing can run any applications that, you know, developers are giving them. There could be, you know, on an application development team or in the many teams within an org, there could be the JavaScript hipsters who are doing, I don't know, TypeScript or something like that. And there have to be these people who are, you know, sold on PHP because they've been sold on PHP for 25 years or something like that. So teams can be very varied and diverse, which is good, I guess. But that sort of complicates the unikernel experience in a lot of ways. And so, like I said, teams are always chasing the dollars. And so you have to justify that compute cost or your hosting costs. And so unikernels and Wasm are individually good ways to bring the cost down. And together, maybe they have the opportunity to do a lot more of that. It's a difficult sort of choice to make because you have to invest a lot of time in sort of redesigning a lot of things that you're already doing. But hey, that's what, you know, provides us job security at the end, I think. But that was my talk today. I just wanted to walk folks through what is theoretically a great idea, and I can show like a bunch of different ways in which I screwed it up if you're interested in discussing that. But if you have any opinions to share, you know, I'm at the registration desk all day, so feel free to stop by, and thank you for being here today.
Does anybody have any questions for Rob? Yeah, we got one back here.
And I just need to just dumb down a little bit. You were showing a VM, the operating system and everything, and then you were showing that. Is this something we can run on bare metal or?
Yes, absolutely.
Okay, but also you would run it inside a VM or
as long as you can slap a hypervisor onto
right.
Things. But here's the thing about unikernels. there's a way you can compile a unikernel to run on bare metal. The unikernel architecture is capable of running on hypervisors, but there is a way for you to do unikernels on bare metal. And so that diagram might not apply exactly to the bare metal scenario, but you can find the right unikernel modules in order to compile to run on bare metal. In a Kubernetes, so this is not a great way to think about how you would do container orchestration, for example, which is why it's not in KubeCon and it's at Rejekts. But this is intended to help run unikernels on different kinds of infrastructure. So it's intended to run different applications on different kinds of infrastructure, not necessarily orchestrated as containers the way we think about applications in the Kubernetes world. I don't imagine so. Yeah, but that might be a good talk for Rejekts in London. Let me think about it. I don't think the container architecture would apply here. Yeah. 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 Yeah, I think Kubernetes is a good way to run on any architecture, but I still feel it's slightly independent of what they're trying to do with unikernels, with the underlying technology pieces. It's two different ways to chase after write once, run anywhere, I guess. So there's a lot of edge and IoT applications that are reported to run in production with unikernels. I've seen very few examples of cloud-based applications, but they're still out there. There's a bunch of different references you can look. Yes. Yep. It's a good architecture that they can experiment with. Yes. Yes.
If you did want to run unikernels inside of Kubernetes, could you use something like KubeVirt just as like another way to orchestrate the virtual machines for your unikernel?
I mean, the best answer I guess I can give is maybe, but the truth is I don't know.
Have you ever gotten it to work with libvirt or
No, I have
QEMU?
not. No,
Okay.
I have not tried.
All right, well, that wraps up our time for Ram's talk. We're going to have a 20-minute break, and then we can meet back in here for our final session of the day in the Flex space.
Thanks.
Thank you. So hello everyone, hope you're having a blast at Rejekts this year. I'm Avni, I am product manager at Intuit Kubernetes service, and I have with me my awesome colleague and awesome engineer, Shell, who is engineer at IKS as well. And this talk is going to be about abstracting Kubernetes layer and our journey in doing that at Intuit. So just a brief glance on our agenda for today. We're going to cover background about Intuit and its infrastructure at a glance, and then all the challenges that come up with running a Kubernetes layer at scale. And then we would cover on our abstracted platform that we call it as AIR and its benefits. And then Shell will walk through the entire migration journey that we did with migrating from the custom today's world to the AIR world. And we'll have a learning section, and we'll close it off with a Q&A. So let's look at Intuit's background and our infrastructure at a glance. So for those of you who don't know Intuit, Intuit is a global fintech company that builds several financial products based on an AI-driven expert platform. So if you've used TurboTax for tax prep or used QuickBooks for accounting, know that you're running on a Kubernetes layer, which is AI native. And this development platform serves around 100 million customers across our financial products like MailChimp, Credit Karma, TurboTax, and QuickBooks. And we're really excited to be here and give back to the community our learnings. A little more about our AI native development platform and its scale. So we have 4 major pillars in our platform, one being AI-powered app experiences, The second one is around AI-assisted development, coding testing. So like AI-generated code, etc., comes in that pillar. So we've been able to see a boost in our developer velocity that's around 8 times. And then we have AI-powered app-centric runtime. And with this app-centric runtime, we are able to achieve around 60 billion machine learning predictions per day. Last but not the least, we have smart operations using AIOps, which has helped us in unlocking around 40 million plus AIOps inferences per day. So let's look at 2 personas that deal with our platform on a day-to-day basis. The first one is the service developer persona. We have a thriving community at Intuit with around 7,000 plus developers whose focus is on building the app logic, coding, and shipping it faster. And then we have the platform persona. So these are the experts who actually expose the interfaces and capabilities to the service persona to accomplish their tasks. And so if a developer needs to manage an application in Kubernetes, that person doesn't need to spend years trying to understand how Kubernetes works. So we need to make sure that the capabilities and interfaces are exposed in a self-serve manner so that our service developer doesn't have to be really a guru in understanding all the Kubernetes primitives and the nitty-gritties. So let's look at the challenges that come up when we work at scale at Intuit. So these are the 3 broad challenges that we experienced. One was steep learning curve. So we do see a lot of our developers who struggle with understanding Kubernetes internals and APIs. And their focus necessarily should not be in really understanding Kubernetes, but rather coding. So they do find themselves dwindling in these nitty-gritties and a lot of configurations to be done to onboard on Kubernetes. And then if any misconfiguration happens, they really juggle with finding a lot of troubleshooting help. The second bucket is around the inner loop cycle, which is mostly local development with dependencies, so like local testing on laptops and so on and so forth. And the third one is tech refreshers need migrations. So let's take, for example, any version updates. So adapting to newer Kubernetes API resources with each platform upgrade disrupts developer workflows. And if there is any new technology integration, let's say service mesh, then we had to work with the developer teams to have this new tech stack. And then, of course, migration mandates, if at all. We would have to, again, work with the service developer teams on migrating them to the new tech stack or any sort of upgrade. And this really causes a lot of burden on service teams in addition to building their apps. And what we figured out is that these challenges are not unique to Intuit. We see that a lot of end users face similar obstacles. So this is what we call where we are today. We call it custom. So just trying to derive an analogy here, it's essentially like managing an event by yourself entirely. So like, how many people should it be catered to, make it 10 plates, 10 replicas, deliver it to my doorstep, and all of these decisions does not necessarily is something that the service developer should be focusing on, right? Let me translate it to what it looks like on our developer portal. So when a user comes on our dev portal where our capabilities are exposed, they first create an asset, which is an atomic form of deployment on dev portal. Then they go and develop and deploy their app, and the story doesn't end there. They have to now start understanding Kubernetes and how they can configure the Kubernetes primitives in their deployment repo. And after that, they onboard to API Gateway to expose it to the internet. And if they want east to west communication, they also have to onboard to service mesh. And after doing all of these configurations, they end up testing it end to end. And after that, if they have to do load testing, let's say on a weekly cadence, they find themselves doing load testing, adjusting min-max replicas, and performing migrations quarterly to stay up to date. Again, this last point runs for perpetuity. And this can cause your developer to go crazy. they now not only have to focus on their app logic, coding that day to day, but now they also struggle with maintaining the Kubernetes YAMLs. Where we want to be is what we are calling the abstracted platform AIR. AIR stands for AI powered. So it should be like you are not being the event planner, the event is being planned for you. So more like done for you, hands-free kind of experience. And what it looks like is that now as a service owner, you should only be focusing around your app. So translating application needs to platform needs would mean that the platform is able to take the application intent from the user and able to translate it to the infrastructure nitty-gritties that is then applied in the cluster. So everything that was around configuring and managing the platform-related stuff, it should be managed by the platform essentially. So I did cover this in our initial slide, but just wanted to add more context, and I would elaborate on Intuit's development platform. So at the top, we have our dev portal, which is like the front door for exposing those self-serve capabilities that the service owner can use in accomplishing their tasks. And then our focus is going to be the app-centric runtime and traffic management, which we call IKS AIR. IKS stands for the Intuit Kubernetes Service, which is our Intuit's Kubernetes layer. And AIR is that abstracted platform that we have built on IKS. And then beneath, we have the operational data lake as well. That's essentially a rich data set for visibility into how all our apps are developed, deployed, and run. So AIR has three broad categories. First one is the application-centric runtime, which is essentially where we have one unified abstracted specification that captures the app intent. And also, our smart auto-scaling solution is part of this application-centric runtime. But just the runtime won't build the entire abstracted platform. We also had to make sure that our traffic management is abstracted as well, for which we have unified our API gateway and service mesh configuration, which helps in easy maintenance of the unified traffic configuration as well. And third, we realized that with an abstracted platform comes the responsibility on the platform to help developers in debugging their deployments without really having to know the Kubernetes nitty-gritties. So for that, we've built a lot of pave roads that user can use to debug their applications without necessarily having to know Kubernetes. And I wanted to highlight the application specification that we have as part of the runtime. It's comprised of components and traits, and it's heavily influenced by the open application model. So components would represent the individual values of functionality, like a web service, a cron job, and even consumer type of workload. And then the traits can further modify or change the behavior of the component it is applied to. So like environment variables or supplying config map would be part of the trait. Now I would like to pass it on to Shell to show how we migrated from custom, that is today's world, to our abstracted AIR platform. Shell, over to you.
Yeah, thanks, Avni, for setting context on what we have built on AIR as a platform. And I'm going to be talking about how we move our existing workload to AIR. So just to brief you up, how does the journey look like? So if we take a single application into an example right now with the custom paved road that we have, there are like tons of YAMLs the user has to configure. Like there's IAM role, there's rollout, what do they want in their sizing trait, or what do they want in their HPA, or if their application is synced or not, or if it's mesh enabled. And there are a lot more, like where do they want to deploy. We want to translate this user's intent into a single app spec, which we call it AIR app spec or express app spec over here, in a single YAML. And this captures the user's intent from like 10 different YAMLs to a single YAML, where we try to take just the user intent and we bake in the platform intent. So this entire journey will share how we do this. And then probably, yeah, we think of, before going there, like what do everyone think, like what platform migrations are to app developers? They are boring. We want to make it intuitive and keep it very simple and keep the user engaged rather than making it burdensome for user. We wanted to have a first-class experience for all of this. But before jumping into the migration, what is the background of current Intuit's architecture? So we have around like 2,500 services in production. And when I say services, they have tons of APIs underneath it. And since the services are just directly deployed on Kubernetes today, they are using a paved path, but a lot of developers are unaware about how or what are the best practices of Kubernetes. So they have their unique configuration, and a lot of services are anti-pattern. So how do we take all those services and move them to a unique pattern following like the 12 app factors? And we want to do all of this in real time. So meaning a user should be able to move to Air, but not just move to Air. They should be able to try out Air and custom at the same time. And once they try out, they have that liberty or decision to either stay on Air or move back to custom without affecting their current production workload. So this is our background. Now, if I quickly jump the gears over here, how does the flow look like? And what I said, how does the system look like? So this is an overwhelmed custom developer who just decides to go to dev portal one day because he's tired of maintaining YAMLs. And he's like, okay, I want to begin migration. It's all self-serve. Let's see, we'll figure out what happens later on. So once they click begin migration, we check if migration is allowed or not. If migration is allowed for this scenario, yes, let's assume it's allowed. We create AirStack. And AirStack, it's a paved road, so there are like Splunk, Argo, and hell lot of other things, namespaces that gets created behind the scenes. And once the AirStack is created, we let users dial traffic between custom and Air. So rather than we do like switch all the traffic to Air, we let users modify or identify what is the need over here. So think of a canary deployment where a user is able to dial traffic. Only thing we check is if the traffic is dialed 100% to Air, that's when the next step is unlocked. In this case, the traffic is not dialed 100% to Air, so user is probably testing or fixing their Air environment. And if everything's working fine, in this case, let's assume the testing pass, a user is able to complete its migration in this scenario. So we see this custom user who's overwhelmed is now able to complete migration, and their services are on Air, and they become happy out of the box. Another scenario is where a migration is not allowed. So there might be some anti-patterns which the automation doesn't support today. We take that feedback, but in this case, we let the service stay on custom rather than inducing any risk to their traffic. The third scenario is, in any case, when they start to dial traffic, the testings fail. So one of the options they unlock is cancel migration, but no, they love Air, they want to stay on Air. So they come back and try to finish this loop to fix the Air environment and eventually move all the traffic to Air, and they are able to complete the migration, and again, boom. The last scenario which we don't like is the user somehow doesn't understand the benefits of Air, or they don't get it, and they try to cancel the migration, and again, they stay on custom. But majority of the times, we try to understand the customer's need and then translate that to a complete migration scenario. Now, how does this look internally? So we'll be focusing on when migration is allowed, like how do we validate? So there are tons of things that needs to be validated, like look at the user's intent, user's YAMLs, and also identify. So some simplest example is we look at their current K8s manifest, how they look like, what's their Argo sync status, or if their service is running, or if they're actually taking traffic or not, because we want to vend out kind of apples to apples. If their services are running, we want to vend out a running service in Air rather than asking users for some feedback. And we also check for compatibility, like if they are following some good patterns or if they're anti-pattern or something. There are like 35 to 40 checks we do behind the scenes before letting a user migrate their services. And once the user is completing all of the checks, this is the UI where a particular user goes to begin Air migration, and they probably see that, okay, one of their controllers or one of the component is failing. They haven't have external endpoint or API gateway endpoint. So somehow the user identifies, okay, they have to fix, and they fix, and this is how their validation looks like now. They again go to begin Air migration. They go over here and they see, okay, everything's green in this particular screenshot that we see, and a user is able to migrate to Air right here. Now, once the validation is passed, how do we end up creating the entire air stack? So again, as we do in validation, we do a little more deep dive in this particular case that we call it inspection. And this inspection, we actually get, okay, what IAM role or what are the policies a user is trying to connect to, or what cluster they are currently deployed on, because we want to be able to deploy on the same cluster to avoid all the transit gateway connectivities or any VPC peering that they have done. Or what are their current min and max replica. We have autoscaling built in, but to start off them on air, we want to keep the same intent rather than messing with things. And once we get the control over their application, we go full in and we go all in, and then we identify. In this particular case, we identify they have some environment variable and a Jacoco port that needs to be opened up. So all of this intent kind of comes in. And also we validate their app properties. We not just validate the deployment properties, but we also validate the app properties, if their mesh port is opened or not. And after all of this, the last thing is to validate if the service is up and running. To do all of this, we take this bunch of YAMLs and translate that into app spec. So over here, we would have identified that this service is fitting the category of a web service. So it's probably a REST producer. And they want to run a particular image in each of the environments. So that's what the intent got baked in. And they have some ports that needs to be carried over and some environment variables. So the transformer or the automation identified what needs to be done. Also, we bake into a feature branch called air migration rather than putting everything into their master. We are GitOps based. So we want to run both the environments in parallel, which we shortly see in the demo. And on the app repo, we want to create some artifacts over there, like add a Jenkins step or maybe open up some mesh port or add a new air profile, because we want these services to come on a paved path or a best practices. So once user merges all of this PR in, this is direct commit, that is a PR on user's repo. They merge in, their manifest gets generated. And this is plain old Kubernetes manifest, which all of us understand. Now, once this goes in, what are the user actions over here? If a user has some IAM role, they connect to DynamoDB, RDS, or S3 or another resource in their resource account, they probably need to set up the IAM role because the namespaces are new. But it is not a troublesome process now, because they'll be able to see it real time from the debug shell if their connectivity went through. They don't have to go into the clusters anymore. They validate whether the app is running or not. So over here, we see that the air app came up and everything's green, the green bar we see. So the app is up and running. If it's not, probably, there might be some feedback loop which needs to be fixed. And if everything is running, they get this awesome UI to start dialing traffic between the environments. So again, more like Canary, they dial however they feel the need, and this loop completes. So going forward, we'll slowly go into the demo. Over here, let me pull this up. I'll just stay here. Sorry. So this is the developer portal that a user will interact with, and this is most of their scenarios. So let's say this is, I have, for this demo, I have configured a custom service. So this is a custom service and which a user decides, okay, let's say I begin air migration. Everything might be green over here. And okay, I confirm migrating to air. And once this is done, we get a view something like this. So this is a service that is migrated, and to start off with, we see that, okay, they'll have two endpoints, one for air and one for their existing service. But they'll still be able to use the same endpoint based on the traffic dialing. So users, dependency, upstream, downstream, nothing changes over here. The only thing that changes is that, okay, user has to start dialing traffic. This is the awesome UI that comes where this is where a user starts migrating from. So this is IKS to air. And this is where they dial to air. Now, if I go into traffic dial, and I say, okay, dial traffic for migration, we identified that this service is fine. We have 5% in custom. But now we validated, okay, everything's running fine. I dial 100% to air. And this gets applied real time, like the way we see here. Another scenario is a user should be able to deploy their code changes because they'll be actively making code changes. They want to be able to deploy to both the environments at the same time. So the pipeline that they get configured is looking more like this. Sorry. Too many things. Let's go from here. So their pipeline actually remains the same. We don't change anything over here in the pipeline except for the new step that gets added. So if you look at Blue Ocean over here, this literally shows that, okay, we did bunch of things. This is their custom environment. We deploy over there. And at the same time, we also start deploying into their air environment. So user's image gets baked into it both of the places. Now, based on some scenarios, once the traffic dial is done and everything's complete, user can either, over here, yeah, definitely some steps are remaining. A user should be able to complete migration or cancel migration as well, and which either gives away one of these tags and user is able to retain their entire intent as is. So what are the learnings out of this? So one of the learnings from, there are a lot of learnings. So what we have done is we are iterative. This is not the final version, or whatever we went out, we take feedback from the user. So first learning was like a user should be able to deploy custom and air simultaneously. We came up with a pipeline which allows us to do that. If a service is tier 1, probably we need tiering-based traffic dialing rather than a user doing fat fingering and doing 100% to a random environment. We are doing a tiering-based. This is all self-serve UI-based, but it literally takes like one sprint of dev engineer time. And now how do we validate a particular, whether their performance is working fine or not in this particular scenario? So for performance testing, these are two separate environments where a user is running their particular application on. So like this is an open-ended question where we're trying to figure out, do we run two Gatling tests or run the same Gatling test with different experiment ID? We are trying to figure that out. One of the open questions is, how does the event consumer migration look like, or how does the traffic dialing, because if a particular service is consuming from a Kafka topic, then probably traffic dial doesn't make sense here, because as soon as the replica comes up, they'll start consuming from that same topic. Right now, we are creating PRs, but PRs can go stale. Can we direct commit? Do we have that confidence? And since this tool is iterative, we don't want to stop at one of the versions, but we want to keep finding more and more candidates to start migrating to air. And yeah, these are the future enhancements or outcomes that we have come up with, like basically have a single pipeline, better UX for traffic dialing, and this is important where we run batch validation across Intuit's fleet. And this validation will help us identify the next stem. There are some open work as well, like how do we address old timers or legacy services in an automated way? And today, a user needs to do some work to automate the IAM role, like basically set up the new IAM role, but how do we automate this? And that's pretty much it for me, and Avni is going to share the learnings from Abstraction.
Thanks, Shel. That was a seamless manner to migrate. Cool. So as Shel covered the migration journey, I just wanted to take a moment to show some of our learnings from the abstraction layer. Shel already mentioned that PRs can go stale. Today, the deployment repos are, once we vend it out, the service owners own it. So we do expect their approval for deployment repo as well. So that's one of our learnings, that PR commits should not go stale, or we have to prompt them to approve it sooner. How to address users' pre-scaling needs. So auto-scaling engine, we saw that it should also take into consideration the pod startup time. We have a talk about this on Friday KubeCon, so hop in for that as well. We actively look into what drives adoption. So we've seen that folks don't just do like one rollout deployment per namespace, but rather multiple rollouts or multiple workloads like event consumer, web service, and cron jobs together in one namespace. So we see how opinionated we can be with the platform, and we always see the trends in our service developer community. The other two things are about trust and training. With the abstraction layer, we still see a lot of folks asking for kubectl access. So there is a level of trust and a level of training that would go into making understanding about this whole abstraction platform. I already touched on enhancements for autoscaling, but because of the deployment repo being owned by the service owner, we are looking how we can auto-approve something. So mostly pivoting to central DB plus UI kind of approach. And open work, definitely we keep working towards DR strategies, failovers, and integrating new features. So yeah, just a call out on Intuit is heavily invested in open source. We create a lot of open source projects, help in maintaining them, have been a recipient of end user award in 2019 and 22. Yep. So stay in loop and follow us on this QR code for all Intuit open source magic. We have given few presentations in the past around debuggability on abstracted platforms as well as autoscaling. So feel free to give a look at those links. And thank you. We are open for Q&A.
All right. Are there any questions? We got a couple in the audience. We got a minute or two, so.
Just real quick, what's the ultimate end goal for adoption here? Are you shooting for 80%? Are you shooting for 100%? Especially with larger orgs and orgs that have, acquisitions where people are coming in, they already have their own opinionated setup. Are they a target for error, or are they kind of, that would be nice, but we really want to get the kind of 80% of the company to come onto the platform, and there are just going to be some tenants who this isn't a fit?
Yeah,
Thanks.
no, that's a great question. We are focusing on the 80%. As you mentioned, we are trying to see those general standards and practices for the majority of the group. And there would be 20% that we know would be really custom in their needs, so they are not the perfect candidates for air.
Got one or two more. I'm going to go you. If we have time, we'll get to the rest.
You mentioned part of the workflow here is migrating from 10 or however many sort of direct Kubernetes manifests into one new YAML specification. Is that its own sort of first-class Kubernetes object that you're managing with an operator, or is that like a templating layer where you're generating config maps and applying those directly?
So right now it's a templating layer based on customize, and we have our KRM-based model as well. So we render using the plugin. We are not directly applying this as a CR to the cluster. But in future, we definitely have to explore that option as well. Yeah.
Thanks. One quick question. How does this apply to dev environments? Once I migrate to Air, as a developer, I want to have my dev environment with all these features applied. Elaborate.
So we went out all of the environments. So if you're running like 5 environments for your current services, we went out the exact 5 environments for Air as well when we start to migrate you. But it's up to the developer's liberty where you want to start dialing the traffic between both of this environment. So your Air environment gets vended out, but it starts with 0% traffic. So you are actually able to test and debug if there are any issues without even taking traffic. And once you feel confident, you start taking traffic on that environment.
How are you understanding the intent and translating that? Is that just custom code you're doing? Are you leveraging AI to do that? And then how do you see it scaling, as obviously you're going to come out with new breaking changes for your abstraction layer and things like that? Are you planning on trying to make it a more generic model, or kind of what's your thoughts on that?
So right now we are not leveraging AI to understand this because there's a lot of intent baked in. So even today's custom service is based on a paved road. So we understand what the templates have been vended out. And we try to take that, understand what the user's intent is into a new template based on what it just focuses on the app spec. But yeah, definitely given in the out of like Probably in the future we can try leveraging AI, but it will be more generic rather than Intuit specific use case.
Yeah, but just to add on that, we are being very cognizant about how our app spec actually looks like. So we do see the trends and only then have an opinionated view. We don't start with, here it is, you can do everything. We start with, you can do with use case A and then go to B, C, D.
All right. Well, thank you, Avni and Sahil. We appreciate Intuit and your guys' presentation. It's always fascinating to hear about how companies are leveraging these technologies in production. This is our last session before lunch that's down here for the online viewers. So the next session will be in about 2 minutes up in the theater space. And then our next session down here in the flex space will be at 14:35 after we get back from the lunch break. So thank you guys all very much for joining me. Thank you.
We have an opening in our marketing department. I'm just saying, if you're interested. Oh, nice. But it's a good idea. I will use it. coming to Salt Lake City. I guess not because of me, but having said that, I'm still very happy that you came. So we are going to talk about threat detection strategies around Kubernetes. This is a 30-minute talk. This is obviously not enough to discuss this topic. Therefore, we are going to be like very up here, and somewhere in the middle I will jump down and go up, and like we'll try, but I will try to make sense here about everything. And my point is really to talk a little bit about the open source projects around Kubernetes and threat detection, their different threat detection strategies through different examples. So just a few things about myself. I'm Ben, one of the maintainers of the CNCF project Kubescape. This is my 4th talk in Native Rejekts, which means that I get rejected a lot by KubeCon. But having said, I'm in the program community of KubeCon, therefore, obviously I cannot accept it too much there. So we had a world, even the security world, we had like a few years when everything was about agentless and posture. And today we start to see a new wave of getting back the focus to the runtime and runtime detection and response and protection world, which is, I think it's very healthy. And it's really something that, since this is the place I'm coming from in my career, it's something that's really good for me as well personally, because it's my home court. So we're going to talk about, I will give a few slides here about a little bit defining the problem space. Then I will take 3 open source projects, all of them CNCF projects that are trying to answer these problems. I will bring you 3 attack scenarios and how these different projects are behaving under these attack scenarios, what's their value they are giving. And then at the end we'll discuss, we'll try to evaluate together, what's the bottom line here. And again, I'm one of the maintainers of one of those projects, so I will try to be very neutral, but you were warned that I might be not completely objective here. So as I told you, for a long time, for the last few years, we were very focused on application posture, security posture, vulnerability management, configuration scanning, trying to say when and how an attacker can get into your environment, which is, by the way, it's a great thing. It's an important thing. It's a super hard thing to do it right. It's a lot of investment from the security teams, and not just for the security teams, but for DevOps and dev teams, because it's giving a lot of work. But on the other hand, the number of 0 days and number of attacks are going up in cloud environments by all reports. And everyone who is in the security space knows that this is a very complex arena because we don't have open source information for a lot of time. So we don't really know how much attacks are happening because organizations are not really ready to share this information. But there are tons of examples where things were published, and is really seeing a rise in real attacks in real time. Despite that, we have tons of tools that should be assisting us in preventing those attacks. So when today, in this example, there are a lot of, I would say, let's put it like this, there are a lot of commercial solutions that are coming here and giving you runtime protection solutions that are covering a lot of the solution space we are working in. So both endpoints, server nodes, cloud logs, everything together. A lot of them are claiming that they are doing it. There is another question how effective they are, but we are today focusing on not on all the space, but only somewhere around, the Kubernetes, the container workload, and the application phases. This is the place where all these projects are focused on, and therefore this is the. I'm not claiming to talk about all the other layers. So as I told you, we are going to talk today about 3 CNCF projects. First of is Falco. Is here anyone who haven't heard about Falco? No. Oh, you haven't heard. Okay. So Falco is a graduated CNCF project. I think it was graduated in last KubeCon. It's one of the CNCF projects who existed well before Kubernetes was even around. Falco is a rule engine for runtime detection, obviously focused on security. The general idea in Falco is that its rule engine and its language enables you to define different rules and rule sets for different sources of information. The main thing we are going to talk about is system calls events in a Kubernetes node, but Falco is wider and can be connected to very, very different data streams. It's been out for a lot of time, and it's a very, very well-tested project. The second is Tetragon. Tetragon is, I don't know how to exactly define it. It's a sub-project under Cilium, and it's been around for not very long time, but as you know, everyone who knows the Cilium team is a great team with a lot of great professionals around it, and it's I would say it's always a force to reckon with because these are really good guys. But the Tetragon is really focused only on the eBPF side of the detection, and it's a very Kubernetes native project with all the capabilities of syncing data to different outputs and defining rule sets on Kubernetes CRDs. Sorry. Went ahead of. So Player 3 is a project where I'm a maintainer. Kubescape. Kubescape started beforehand about the postures and configuration scanning, vulnerability scanning, and so on. And we had a shift in the project in the past year and a half, where we got a lot of requests from trying to detect runtime attacks, and we connected with, we decided not to implement eBPF on ourselves like the 2 other projects did, but joined forces with the Inspector Gadget team to connect different events in the eBPF and do a very different approach to runtime detection, which is detecting events not just based on rules, like if I see a process that is started from a temp directory and it looks strange, then I need to alert because attacker could do that. But this project is focusing very much on anomaly detection, so trying to define how an application is working, and after a predefined learning period, starting to alert on any deviation on the behavior from that base behavior. So the biggest, the approach here with all 3 is a little bit different. Falco is coming again because they were the first and they are here for 10+ years. They have a bunch of rules. There is a lot of, I would say, tribal knowledge around Falco, documentation, everything that enables to define rules and detection rules around the eBPF stream of Falco. Tetragon is the big difference from Falco is that instead of streaming all the eBPF events of what's happening on a node into a user space application and running a rule engine about that, Tetragon, what it tries to do is evaluating all these events inside the kernel in eBPF, which has a huge advantage on the performance perspective, but it makes the detection rules somewhat limited because they are constrained with all the eBPF constraints around that. And as I told you, Kubescape is more into baselining application behavior and alerting on deviations from baselines. So, as I told you, we are going through 3 attack scenarios and see how these tools are behaving. So the first attack scenario is a command injection. When in this case, an attacker is attacking an application running inside the Kubernetes cluster, and the attacker has identified that there is a command injection attack and is able to send a payload, an HTTP request with a payload to that application, which then spawns a process, a cat /bin cat process, which dumps the service account token of that pod to the std out, and the std out gets back to the attacker through the request, which would be like it's a very simple attack. And just for you to show, why is it not auto starting? So it's a very I've created a demo application for that. So there is this ping tool application, which is the vulnerable application. I can ping any address. Now, as you can see in the next try, I'm not just trying to ping this IP, but also trying to inject a command. Let me stop. Just for everyone who's not understanding that what's happening here, this string is taken by the application and just invoking a shell. And since the semicolon is there, it interprets the ls as an extra command, and therefore the attacker is able to inject the ls command here. So as you can see here up in the response, you see that there was the index HTML and ping PHP is the output of the ls. And now on, I will do as an attacker the real attack here. And I will try to steal the service account token of the pod, which is, again, this attack is, I'm not saying that every application is vulnerable to this attack, but from application security perspective, these are the kind of attack we are very concerned that will happen on a real, in a real environment. And surprise, surprise, we have the service account token in the response. So, oh, sorry. Whoa, how do I switch to the next slide? So, okay, I'm stuck here. So, how these 3 different rules are behaving, and again, guys, I'm sorry, there might be maintainers here of both projects, and maybe they will say, oh, this is not working like this and working that way. It's sure, I'm trying to summarize here the experience. So what happens with Falco with default rule set in this attack was very surprising for me because nothing, it alerted on 0 things. I really expected it to find out that the binsh that was executing here is responding to sending back the data through the network socket, but it didn't. I found a way to enable, to configure this specific thing and to have it alert, but it wasn't very easy. So I needed extra configuration for that. Also, there is a rule in Falco, which is not enabled by default, but you can enable it, and it will alert if the pod is accessing the service account token file. Now, remember this because we'll return to this. There is a problem here. I have to tell you that for Tetragon, I needed to do a lot of massage. The service account token was actually rather easy because there was I could create a policy where with Tetragon, which notify that someone is accessing the service account token. But again, to show you that there was a cat process that was spawned by another process that has a network connection, and the STD out is going there was not possible for me, at least from my limited knowledge. It might be done, but again, take these responses as someone that if I'm failing with my in general knowledge about this area, so a security engineer will also have hard problem defining this. So with KubeScape, what we found out that after the learning period finished, it raised alerts on unexpected processes that were launched and unexpected file access that it detected. So it detected that there was a file that was accessed that wasn't accessed before, and there was a process that started that he didn't saw before. Now I'm bringing you another attack. In this attack, the attacker is not trying to extract the credentials, but uses a server-side request forgery attack on an application, which then creates a request for an AWS API. So the attacker is able to send a payload that causes the application to send a request to AWS. And since this application has credentials to the AWS API, that request will be answered with an OK with the AWS API. In this case, I saw that it's in this request, we are creating a new user in IAM and so on. But I guess you get the gist of the idea. So what work? So I could configure a Falco to alert on access to the AWS metadata service. Again, this is not a rule that is defaultly on in Falco, but there is a rule. The same guy went to Tetragon. I could define, there is an example in Tetragon where I can alert on all the egress communication. And I also could alert on the metadata service communication. It took me configuration, but it worked. With KubeScape, I automatically got alerts on the egress communication, unexpected egress communication, and unexpected access to the metadata service inside without any further configuration. I want you to know that on one hand, we are doing configurations here. Here, we are not really doing configurations, but we also, I'm just going a little bit ahead, we are getting a little bit more vague answers. So these all things that I'm saying that there is unexpected behavior, it might need a little bit more explanation to go deeper of understanding what's happening here behind the scenes. Now, the third example here is a supply chain attack. In this attack, the attacker is able to inject malware into a container image, which then image is pulled into Kubernetes, into the victim cluster, into a pod, the same image, and then a malware client is launched with the infected image, and it connects to a CNC server outside, in the outside world, is waiting for commands. In this case, again, I could, both with Falco and Tetragon, I could configure them to alert on egresses, which in general. With KubeScape, there was an interesting thing, because if the malware worked during the learning period, then KubeScape said, well, this is normal behavior, so like it's okay. If it was activated after the learning period, then KubeScape alerted on all the new process that it was launched and all the unexpected external communications. So let's go into the last part of where we are configuring, comparing these things through configuration. So both in case of Tetragon and Falco, and this is like coming from right now from me, but I've been talking to a lot of end users as well in the past years. In Falco was very configuration heavy. I've talked to organizations running like 200,000 workloads in their Kubernetes clusters, and it is a mayhem for them to the security team to configure Falco properly and not to have a lot of alerts. Think about it again, the example I told you about accessing the service account token. The security team doesn't necessarily know which workloads have to access the service account token. There are workloads that has to. This is their normal work. So configuring them is very hard, and then following up changes in these environments are very hard. Same goes more or less to Tetragon. I had to tell here that I had like hard time making Tetragon detecting a few things here. But again, I appreciate Tetragon for how it's built, and I know that it's improving all the time. From a KubeScape perspective, besides the supply chain attack, when there is a question of whether the supply chain attack happens in the learning period or afterwards, it caught these attacks very nicely and got alerts. Now, as I said, the first question is a service account access is an issue or not, or accessing a metadata service, or any kind of behavior, writing into the temp directory. Is it a suspicious behavior or normal behavior of pod? These are very hard things to answer for security persona in a scaled environment. The second thing is the way that things are customized and fine-tuned. So, So Falco, again, has a policy language, a rule language. It's very customizable, again, very used broadly. If someone learns it and able to debug it and so on, it's something it's very, very customizable. Same goes to Tetragon. Again, a caveat here, there are some things that Falco is able to detect very smoothly, like there is an open issue, I think, on Tetragon, which I don't know if it's still an open issue, but for example, detecting reverse shells, which is just checking where is the STD out and the STD in of the process is going to a network socket or not. And Tetragon for a long time had an open issue that it wasn't, like in the policy language of Tetragon, you couldn't define such a detection, very basic detection rule. KubeScape, on the other hand, is not a very easy, compared to Falco, it's not easily customizable. The baselines are CRDs, and the baselines can be really nicely managed. They are very, very, very easy to extend if something was missed in the baselining period. But in general, if you want to write a new detection rule, you have to write it in Go and add it to. And by the way, here we took a deliberate decision not to use a rule engine because it's very hard on the CPU from a performance perspective. So, and this brings us to the second big issue I see. Constant changes in environments are very hard to follow up with these first two rules, and therefore the ability to self-configure, as I see it, is a very important property of any runtime detection. Otherwise, it's very hard in our modern environment to follow up all these changes. So the third thing I wanted to use as comparison is explainability, I call it. So Falco and Tetragon are very clear about what they are alerting on. So you are writing a rule, the alert contains the rule name, then you know that this rule failed. In KubeScape, you have an unexpected process. You have to go into the details of the alert and read all the fields in order to, okay, which process, which pod, what happened. These are very rudimentary information sometimes. Sometimes it's more clear. And the performance comparison from Falco, I think that most of the people who used Falco know that Falco is really hard on CPU. It simply happens because all the events which are happening in the kernel are streamed into all the file opens, new processes, everything are streamed into the user space component, and there is a rule engine that's going over them and evaluating it. And the sheer number that at scale thing that has to be processed by Falco is like very huge, and it can take 20% of a single CPU sometimes. Tetragon, as opposed to that, since they moved all this problem to the kernel, they are bypassing this problem, and they are able to process the rules in the kernel space. Therefore, they are not paying all the overhead of transferring information into the user space, and therefore they are very low on CPU and low on RAM. KubeScape is also low on CPU, pretty much because all these events are not evaluated by a rule engine, but very simple, efficient Go code. Again, this is why we have chosen to do all the evaluation in Go functions and not in a interpreter. But I have to mark here that from a RAM perspective, it uses more memory because the baselines are stored in the memory. It's not a lot, but it's still it's something I wanted to point to. So, in general, takeaways. So Falco is, again, it's a very, I usually tell people that Falco is like an academic project, like it's how someone who has like a blackboard and trying to write up how this thing should work is working, and it's very nice and everything promises very good. But in the practice, it seems to have both from the adoption side in the world, how many big companies are using it, and both from, in general, it seems to have a glass ceiling that it's not able to break, because I think that one of the biggest problems is the configuration, how hard it is at scale, how hard it is to configure. And the other is obviously the performance. In cloud, taking 10-20% of the CPU has a direct cost on the organization's AWS billing. The Tetragon is again, I believe that this project is going to improve a lot in the upcoming years. I think it's very early. So for a security, I don't really see security personnel, except of a few geeks like myself, not really investing too much time, because it's very hard to make it right and detect the things we want to detect. And I again, obviously, because this is a project I belong to, so then anomaly detection, I think it's very, very a big differentiator on the side of KubeScape. So KubeScape, the ability to work not on very specific rules and trying to guess what is going to be the next 0 day, but by default detecting all these anomalies that are actually a cause of an attack is super interesting. And if in 2 years we'll see that the adoption grows, it will be proving that our point was okay on here. Thank you, and questions?
You mentioned a learning period for KubeScape. Can you tell what that is and what happens during that? And do the other two tools have a learning period?
Yeah. So first of all, in KubeScape, there is a predefined learning period which you can control, during installation for all the pods, which is 24 hours. It simply is just something we learned over the time in our deployments, that you need at least 24 hours because they are simply at scale. There are too many workloads that have daily jobs, and we have to cover it in the baseline. During that time, KubeScape is writing the behavior into CRDs called application profiles, which are really cool, even not just for the sake of the detection, but in general defining how an application works, what kind of files it uses, what kind of network connections it does, what kind of processes we're running, and so on. And it collects them into these CRDs. And during the detection phase, after 24 hours, every event is compared to this baseline. And all the other tools, I've heard that for, I don't know, might not be right, but I think the owners of the project Falco Sysdig does have a learning feature, but I don't really know how it works, so I don't want to really go into that.
So you mentioned like a high performance utilization, with respect to Falco. Was there like, did you try that like with a specific driver, like with the kernel module driver or the modern eBPF driver?
Only modern eBPF.
Okay, and with the default rules engine, or did you get rid of the default rule engine and then write your specific rules engine?
No, I two things. Like during this testing, I used the default rule engine. I added rules and removed rules. I cannot, like all the other people I've talking to, like who are like try to use Falco and like again at big scale, I don't know what they use, what kind of rule engine they tried out. So I cannot comment on that.
Last question, probably.
You mentioned that alerting was sort of the test as to whether or not it was working. Any of these tools, are they actually stopping the behavior when it sees that a malicious action is occurring?
Stopping behavior. Oh, so prevention.
Preventing? Yeah.
Prevention. So in eBPF, prevention is not a very simple thing. I don't know if Tetragon does it today, but if I have to guess that there will be, the first tool that will do prevention is going to be Tetragon, because just their sheer knowledge of eBPF is there that they know how to do that. And if anyone is interested, by the way, tomorrow I have a talk with a friend from Microsoft at eBPF Day, where we are going to talk of how to do prevention through eBPF. It's not a simple thing, but it's super interesting. There are problems there as well. But in general, by default, none of these are doing prevention.
I'll take one more.
And I have a last comment as well. So,
did you publish like the Falco rules that you did end up using to detect those attacks and the resource utilization benchmarks?
No, but I will. It's a right comment. I will publish it. I will publish it afterwards. I will go back to the hotel today or tomorrow, and I will publish it.
Awesome. Thank you.
Yep.
So just one thing. If anyone's interested in swag for KubeScape, should come to the KubeScape Project Pavilion on which day? Thursday afternoon, and meet the KubeScape team. Okay, thank you very much.
Great. Thank you so much for that.
Hello. Hello.
Hey, good afternoon, everyone. So let us now move to the next talk for this track. And this one is on scaling private LLM model services with K-Serve and Model Car OCI. And this is being presented by Mayuresh Krishna, who is the CTO and co-founder at Initialize.ai. So Mayuresh, the stage is all yours.
Okay, yeah, I'm good. So yeah, thank you for joining, and thank you for being here for my talk. So I'll talk a little bit about how K-Serve and what K-Serve does in helping in inferencing for whether it's large language models or any kind of models. And we'll kind of dive into a little bit of like how we can use Model Car OCI to make it much more efficient. To get started, a quick background about me. My name is Mayuresh Krishna. I go by MK to make it easy for everyone to remember me. I'm co-founder of Initialize, ex-VMware, ex-Pivotal, and you can find me on Twitter at Mayuresh Krishna. I couldn't get MK. I guess if I would have gone on Twitter in 2009, 2008, I might have gotten an MK handle, but I couldn't get it later on. Just quickly, the overview of the talk. We are going to talk about model serving in general. What are the challenges, or what does model serving entails? We'll look at what K-Serve is and how K-Serve helps in the whole inferencing area of model serving. And then we'll look at K-Serve LLM runtime to look at how K-Serve helps in large language model runtime serving. And then we'll get into the Model Car OCI to just kind of understand what is Model Car OCI and how it can help. And then we'll get into a little bit of Q&A after that. In this whole talk, after we get into the K-Serve LLM runtime, I'll do a little bit of a demo of how that works with K-Serve. And then I'll kind of try to show a difference between when you run out-of-the-box LLM runtime versus you run a Model Car OCI, what is the difference? So just to kind of set the stage on model serving is an integral part of the machine learning lifecycle overall. If you think of it, a lot of AI and data science engineering is spent, or time is spent on the training side of the world, where you're training your models, you're fine-tuning your models. And the data engineers are generally not very apt at, like, how do you run it at scale, right? It works on my laptop. I'm able to train my model, fine-tune it. I can spin up my fast API and use it, but now how do I get it to production and I scale it in production? And that's where the model serving comes into play in the whole life cycle. And if you think of it, the whole idea of model serving, and then when you delve into ML infrastructure, it's complex. And we are talking about an era where almost every month new large language model versions are coming out from different organizations. And if you are fine-tuning based on some of those, the base large language models, and if it takes you like 3 months, 6 months to deploy your fine-tuned model, you're already behind the curve, right? So, and that's why I put it out there, like 1 hour here is about 7 years in Earth. So 1 month not able to deploy your application or model inference in production is almost losing out to your base large language model has now moved on, and you have a newer ones, and you have to go back and fine-tune it. So it is important to kind of simplify how do you serve your models in production. So some of the things which gets into consideration of deploying large language models or any models as such for inferencing. The concept of deploying model as a microservices is a common strategy which is kind of played out, which is being used. And essentially, the idea is that similar to an application where you deploy as a microservice and then consume it, you can deploy your models as a microservice and then inference it. Most of the models that you're deploying for inferencing, you'll have some sort of an API or a REST or a gRPC endpoint, or otherwise kind of exposing that so that applications can consume it and use that inferencing data for any kind of whatever business use case you have on top of that model. But there are considerations which you have to take into when you are deploying these models and inferencing it. Like, how do you containerize these models? Like, is containerizing and deploying on Kubernetes is a good way to do that. And one of the things which kind of helps in doing that is because the infra teams are very well versed with, at this point, deploying applications with containers and Kubernetes. Can we extend that whole construct and standardization on deploying your models and using that? And for them, when you do that, how do you containerize those models? Are the inference response times as containers good enough for serving your models and serving your predictions and inferencing to your applications? And then in the data science area, there are different types of runtimes for model. There are different types of model serving runtimes. How do you make sure that you're able to support that on Kubernetes when you're trying to deploy those model inferencing? Like, for example, some data science engineers would use TensorFlow, some would use PyTorch, some would use Onyx runtime. But there's different runtimes which you could be using, or data science engineers would be using to build their models. And now when you want to inference it, how does infrastructure team or platform engineering team make sure that they're able to provide support across the board for these different types of models coming in from the data science team? So that's where essentially Kserve comes into play. It's essentially, it's supposed to be a one-stop solution for any kind of model runtimes you want to inference on top of Kubernetes. So if you think of it as Kubernetes was built to be kind of a generic engine to enable you to build application platforms on top of that, or if Kserve is kind of something similar to that from model inferencing perspective. It is built as a generic kind of construct on top of Kubernetes, on top of which you could build any specific application and model inferencing construct on. So it supports, it's a performance standardized inference protocol, so it supports different ML runtimes. You can run your Onyx runtimes, you can run your TensorFlow, you can run your PyTorch, and it also supports LLM runtimes, so you can run runtimes like VLLM or Hugging Face accelerators. So essentially, you can have one Kserve setup on your cluster, and you're able to support multiple types of model runtimes on top of it. It gives you additional capabilities, like it gives you serverless construct where you can scale down to 0 for your model inferencing. And it also provides ability to do pre and post processing on those model inferencing which you are trying to do on top of Kserve. It's kind of built on top of the basic infrastructure layers which most of the organizations have who are using Kubernetes. So on top of Kubernetes, it uses Knative and Istio to act as that serverless plane. And then on top of that, Kserve sits as a predictive and generative model inference platform. And if history of Kserve is, if you think of it, it was part of Kubeflow, which is the ML ops platform on top of Kubernetes, and it was kind of split out of, and it used to be called KF Serving back then. It got split out of Kubeflow and KF Serving into its own project called as Kserve, which is kind of supported by community now as an independent serving capability. So to give an idea of like how this works from inferencing perspective, and the whole goal is to make it much more easy and simple for platform engineers to make that useful for dev teams as well as data science teams to consume it. So you can look at it over here. Let me see where's my, yeah. So over here you have the definition of the cluster serving runtime, where you define what are the different kinds of runtimes you're making available. These are the different ML runtimes, machine learning runtimes. So you could, this one is for sklearn server, which is like scikit, and then you could have like other runtime defined on your cluster for like say ML server, PyTorch, VLLM. So you can define those runtime servers, and you can say that what kind of supported format that runtime supports. And then for the user who are trying to inference or create or deploy a model and inference from that is where you specify your inference service and you provide your model format and then you provide where your model sits. The storage URI supports different types of storages. It supports S3 or object storage. You can pull it from a file system. You can also pull it from container registry, or you can pull it from like Hugging Face repository. So storage URI supports different ways of pulling the models from. And then you can specify what runtime to use, or if the auto select is true over there in your runtime configuration, then you can just, based on model format, it will automatically choose that runtime for that model. So for me to inference my model, which I've built, say for example, a scikit model, I just have to deploy this YAML file, and I'll get an inference endpoint. And I would be able to now consume that endpoint and call my APIs on top of it to inference from it. So the goal of Kserve is it makes it much more simpler to kind of stitch together all the things which is needed to inference that model, for either whether it's the under hood ML runtime, as well as whatever model storage you need, and how do you plug it together and bring it up front as a consumable endpoint. Now, so on the LLM side, Kserve LLM runtime supports essentially two different serving runtimes. One is Hugging Face LLM serving runtime, and the other one is ThoughtServe LLM serving runtime. Within the Hugging Face server runtime, it implements two backends, which is the Hugging Face Accelerator backend, as well as it implements the VLLM backend. Have any of you have heard of VLLM runtime from models perspective? So VLLM is pretty widely used at this point in the industry for ML runtime. It's kind of used by some of the largest inferencing companies out there in the AI space. So it's pretty powerful. It has pretty solid backing from community perspective behind it as well. And most of the projects which are trying to abstract and make inferencing simple are somehow under the hood using VLLM to make it happen. So Kserve does that too. Kserve under the hood uses VLLM. Out of the box, it uses VLLM, and you can choose to use Hugging Face Accelerator as well if you want to. Out of the box, kind of builds out some of the ML tasks, so you don't even have to kind of build it yourself. You can get the LLM model, and you can have some of these tasks already available to you, like text classification, token classification, generation. You can extend that to build your own other task capabilities based on the model which you have and it supports. But some of the common tasks on some of these LLM models are out of the box supported by the Hugging Face LLM runtime. And then the other one is the ThoughtServe LLM serving runtime, but it's essentially which kind of gives you the ability to run your ThoughtServe ML runtime as an LLM runtime on Kserve itself. So what I'll do now is I'll quickly show an example of using the Hugging Face LLM serving runtime and how it works on Kserve. Let's see if I can bring this up here. Yeah, I should have not extended the desktop. Now I cannot see where it is. There you go. All right, so one other thing I'll bring over there is the code itself. Say again? Yeah, let's do that. That's easier. Instead of going back and forth, mirror. Come back. There you go. All right, so this is my Hugging Face runtime. I am using Google T5 Small just for this demo, so that it does not take a lot of time to pull it down and run it. I'm using backend as my backend is Hugging Face, and I'm specifying my model format. Since I'm pulling this from Hugging Face, I'm specifying my token, so I've deployed a secret where my Hugging Face token is. And I'm specifying the resource requirements. I'm specifying that I want 3 CPU, 6G memory, and I'm specifying mixed slice, which is a 10G mixed slice out of 80G A100 machine. And that's it. So this is all I need to get this particular large language model up and running and inferencing on K-serve. So I can go here and see if this is big enough. So when I apply this, let me pull up, it spins up an inference service called as Google T5. And it will start spinning up the inference predictor pod for me, which is for this particular model. And if I go into the logs for this, their work. Yeah. So if you look at the payload, it loaded tokenizer over here, and then it loaded the Hugging Face model from path Google T5 T-small. So it actually went out to the Hugging Face and pulled this model. This is a small model. I think it's about maybe 200 MB or 300 MB model. It's a T5 small model. So it took about, about 2 seconds for it to pull 200 MB model. And then registered the model and started up the server. So now I can consume this. I will copy my port forward. Which one is that? This one. And go to my Postman. So I'm just calling this T5 model. I'm giving it a prompt, and I'm not streaming over here so that I can see the entire output here. And essentially, so this is one of the things. K-serve automatically serves some of those OpenAI endpoints or standard API OpenAI endpoints for the model which you are trying to serve over here. So I can just directly go to that endpoint and call this and get a response back. And I should be able to see in my logs as well what happened here. But essentially now, even if I'm experimenting with things like OpenAI, I can actually go change nothing on my code and just go to point my inference server, and the same thing would work over here. So for example, if you're doing chat completion, text completion, summarization, any of these tasks on, say, OpenAI-based APIs, you can deploy your own model now, whether it's T5, whether it's Llama models, Mistral models, and just point your code to that. Now, sure, it won't be exactly the same as using the OpenAI from the response perspective. It's based on each LLM model's capability. But essentially, you are able to move to different model without having to change any code, just pointing your endpoint to now a K-serve deployed model inference endpoint. So that's how simple it is to deploy a model and get it up and running. Now going back to my slides. Will it work? Yeah. That was a demo. So quickly on, like, we just saw that it pulled the models from Hugging Face and it served it. That was a pretty small model, 200 MB approximately, so it took 2 seconds. But think of the large models, like if you want to deploy a 400B parameters, Llama 3.1 models, it's like 763 GB to pull down. Llama 3.1 is 140 GB to pull down. Some of these large language models kind of range between 2 GB to 80 GB models in general, which are the open source models available. So when you're pulling down and you're running these as a model inference service and you have to scale, for an example, you're scaling down to 0 so that you don't consume your GPUs just because nobody's using it, and you scale up. or you scale out when you have more transactions, the time for that service to stand up and serve is going to be as long as it takes to download those things, right? So there are different ways to solve for that. You can have your nodes which has all these models already there somehow, and then kind of pre-treat those nodes which you have on your clusters, and then so that it doesn't have to download all the way from Hugging Face. Or one of the things which you can do is, which KServe provides, is using OCI container image of that model as your model to load. So essentially, it uses the constructs which is already built out in Kubernetes to pull down a container image and run it and cache it. So when a new instance of a pod comes up, it's going to use the cache which is already there on the node to serve that model. On a new node, it might still have required to pull it down, but once it's pulled down in one node, in that node, it can scale up and scale down pretty quickly and pretty fast, because now it will be kind of using that model from locally in the disk of the container, which is kind of mounted in the container itself. So it doesn't have to go to Hugging Face. It doesn't have to go to external storage. It can pull it down from there. So just to quickly tell you about it, it reduces the startup times, as I said, low disk space usage, because you're not kind of saving it in different nodes all the time. It enhances the performance. And it is compatible with KServe infrastructure overall to make it happen. So I'll quickly do a deployment for that to give you a demo of it. Let's see, where did my, there you go. Did it go? I went on extension again for some reason. So in this case, I'll deploy this model car and get my pods. If you'll see, in this one, there is an additional container, and that additional container is essentially a container which is serving that model from an OCI image. So if I see the logs of this, in this one, it took about, I would say, 800 millisecond or about a second to load. The difference is small because it's a very small model I was demoing it on, T5 small, 200 MB. But it took about 2 seconds to 2.5 seconds to pull it from Hugging Face, versus it took about less than a second to get it up and running through the mounted OCI image on the node. So that's the primary difference between Model Car OCI. And to quickly show you what it looks like from deployment perspective, you specify your storage URI as your OCI image. And essentially, to build it out, you just pushing your model data folder into the image and pushing that image to your container registry, and that's it. That's all is needed to get it up and running, and then you can use that inference. So that's the kind of the overall talk track. Any questions on any of these aspects?
For KServe, do you also need the GPU? Like, is the GPU mandatory?
It is not. So you can actually serve a lot of these smaller models just GPU. You don't need GPUs to serving those. Like, for example, I can actually do T5 small on a CPU because it's not that big, and it can still give me the performance I need. And some of the things which VLM runtime provides is the ability to do things just on CPU. And even in large language models where it needs GPU, you can share GPU and CPU together and offload some of that. For example, if you are running a very large model which requires 4 GPUs, you can actually do 3 on GPU and share another one through CPU and do CPU offloading. But it's not necessary that you need GPU to run KServe.
But in real life scenario, like for large customers where there's like huge number of users, simultaneous users,
yeah,
have you seen in real life GPUs being used by default?
For larger models. Smaller models, you can still serve on CPU. You would need more CPUs to support it, but smaller models can still be served through CPU. But it does not, like for example, 1B parameter model is still very small, and you would be able to serve through just CPUs and get the performance. Again, test. You would have to test, performance test it, and see if you need how much scale you need to make it happen. But you can still do it with CPU.
One more question is, initially you spoke about from Kubeflow, the case are separated. So
Right.
Can I know what are the difference between, and then what is the use case for even Kubeflow?
Yeah, so Kubeflow is the overall MLOps platform. So you can, if you think the main difference is Kubeflow is training and fine tuning, K-serve is inferencing, right? So when you want to train the models, Kubeflow has the built-in kind of abstraction of like how do you start a job of training, inject your training data to it. Do you have a base model you want to start off of? So it gives you that MLOps capability of training and fine-tuning with Kubeflow. And when you want to inference it, run it in production, your fine-tuned model, or even your base LLM models, that's where the K-serve comes into the play, and you inference it. And the reason, I think one of the primary reasons was the industry driving it to an extent where a lot of data engineers were already using some other tools to do training. Like for example, they were already using Databricks, SageMaker, and all of the things. But when it came down to serving or inferencing and deploying these models in production, that's where the gap was. So I think that split happened to make K-serve independent to be able to be used as just an inferencing engine.
If you want to have RAG, then is it enough to take RAG and integrate with K-serve? There's nothing to be done with Kubeflow, right?
No, so essentially, yeah, so essentially, if you want to do RAG, you get your vector database from somewhere, whether you take it from cloud or you deploy your own, or you can deploy your own vector database as container. And then you have K-serve for model inferencing, so you run your LLMs over here, and you can build your RAG application out of it. Your app, as you saw, that OpenAI API standards were already available, so your Python or Go app, which you're writing to do your RAG application, can just connect to this endpoint for K-serve endpoint for your LLM and your vector database for pushing your embeddings, and you have your RAG application running. So, and K-serve is pretty lightweight. I could have shown it to you, but it's like 4 different things it's running. It's running Istio. I mean, you don't even have to run the full Istio. You do run Istio base, you run K-serve, and you run Knative, and you have your application, your inferencing up and running. And Istio kind of puts out an ingress endpoint for you, or you can deploy a gateway API to do, DNS-based external gateway endpoint for you.
Anyone else? Last one.
So how would this be good for implementing into edge AI, where you would be using CPUs often anyway to pull it to a local device?
Yes, you could. Yeah, you could use it in edge because if you think of it as, in fact, you could look at scenarios where you are running on edge, say something like K3s or even lighter weight Kubernetes construct, and then you're deploying K-serve on top of it, which is not very, it's still lightweight, and run your inferencing through maybe the local registry, or just models pulled into that particular edge device and can serve it from there. So you can pre-warm that edge device, and it doesn't even have to go out of the network to pull anything down. It can just completely serve everything from that edge device. And you can even use things like the NVIDIA edge devices where you just have one GPU on it, and you can even have GPU on those edge devices.
All right, thank you. Applause, please.
Thank you.
All right, yeah. Hi, is this loud? Okay. Hi, welcome. I am Jason Hall from ChainGuard. This is Jed Salazar from Adera. And we're here to talk to you about securing cloud-native applications. Let's get going. Yeah, are you ready? Are you ready for it? Are you ready for it, though? Okay, good, thank you. Needed one woo to proceed. I'm going to start off with a bold claim. Almost all of the vulnerabilities in your software are 100% avoidable. Yeah, bold, bold. I'm going to follow that up with another bold claim. All software is vulnerable eventually. So how do these two things both work together? It may sound like they're in conflict, but they're really not. I like to think, lost it. No, I didn't. I like to think of software and vulnerabilities in particular as sort of this Venn diagram model. Software is the big outer one. We all know what software is, hopefully. If not, you are in the wrong talk. Software is unfortunately written by people, and people make mistakes. So the next level under software is bugs. Bugs are anything software does that was not intended to be that way. There are a number of things you can do to shrink the bug circle inside the software circle. You can write tests. I know it sucks, but you can. You can use a memory-safe language. You can do code reviews. There's a number of very, very good ideas for shrinking the bug circle inside the software circle, and you should do pretty much all of them. But bugs are inevitable. All you can do is shrink that circle, not eliminate it completely. Some percentage of those bugs are vulnerabilities. These are things that make your application vulnerable to an attacker and make your users' data potentially vulnerable as well. Okay. There are a number of things you can do to shrink the vulnerability circle within the bug circle. Again, code review, testing, memory-safe languages. And you can also do a lot to minimize the severity of the vulnerability if it's still there, things like observability, network segmentation, and many, many other things that you should do. And then the last category is 0 days. We'll talk about that in a little bit. So with that in mind, the number one thing you can do to reduce vulnerabilities is remove unnecessary software. Shrink that big circle. You probably don't need it all. If you shrink that big circle, you are shrinking all the other circles at exactly the same time. And that's what ChainGuard does with our minimal base images. We use the term distroless for this. This means generally images that don't need a shell don't include one. Images that don't need a package manager, and it's nearly all of them, don't get one. And only include what software, what dependencies you actually need in those images. So it wouldn't be a ChainGuard talk without the old comparison slide. We have on the left the Python latest image from Docker Hub. These are from, I think, 45 minutes ago when I made this slide. You can see that the Python image is much bigger. It contains many more packages, many more CVEs, and 10 critical CVEs compared to ChainGuard 0. We'll move on to the next one, which is Node latest and ChainGuard Node latest. Same story, smaller, 0 CVEs, 0 critical CVEs. And finally, Ruby, same story, much smaller, fewer packages, 0, 0. Now, the eagle-eyed among you might notice that the number of CVEs and the number of critical CVEs on these slides was actually the same. And you may have thought, wow, Jason just really messed up on these slides, didn't he? And I'm not going to fact check him, so I assume that's right. No, this is actually correct. They contain the same 583 CVEs and the same 10 critical CVEs because the Ruby image and the Node image both contain Python. And Python and all the stuff that supports Python in the image brings in many of the dependencies that bring in those 583 CVEs and the 10 critical ones that you should really be worried about. So the first thing we do is we can just get rid of Python in the Node image, in the Ruby image. You don't need it. If you do need it, you probably know why you need it, but if you don't know if you need it, you don't need it. So let's just get rid of it. But I will I'll continue with another bold claim. Distroless by itself is not enough. Just eliminating unnecessary software is an easy first step, is clearly something you should do, but in and of itself, it is not enough. My next bold claim is that known vulnerabilities are going to be a bigger threat to you than 0 days. And for that, we have to talk about what 0 days are. 0 days are the tiny little circle in the middle. These are unreported vulnerabilities. Generally, when somebody finds a vulnerability in code, they responsibly report it, and the upstream project receives that request and quickly fixes it. Generally, people don't like having vulnerable software, so they fix it, and they make a release, and all is right in the world. When they don't get responsibly reported, those are 0 days. The good news about 0 days is that they are expensive and rare. Generally, these are the purview of nation states trying to attack, large corporations. Generally, these 0 days are very complicated to exploit. It requires bouncing 6 or 7 things off of each other in just the right way just to get those things. I hate to break it to you, but you are probably not worth it. Your blog running on Kubernetes with 3 monthly viewers is probably not going to be, I know it's hard to believe. Your mom loves it, but the blog is just not what North Korea is after. So yeah, there's even a website for all of the known vulnerabilities. It's run by the government, and they tell you everything about all of them. So known vulnerabilities are a lot more common and a lot easier to exploit for regular folks than all of these complicated 0 days that they write spy novels about. Your defense against the known vulnerabilities is shortening the window, is updating quickly when that upstream project fixes the reported vulnerability. And to do that, you have to choose a distro that prioritizes speed. So Wolfie is the Linux distro that backs all of the chain-guard images, and we pick up upstream releases, often within hours, sometimes within 1 hour, and build and release those and put them into our images. This is made possible with lots and lots of automation and hard work and tests, and we do it so that you don't have to. Unfortunately, this means it's still on you to update often. We can only produce images quickly for you. It's up to you to pick up those updates, test, validate, and do releases. Long gone are the days of the quarterly release, the monthly release, the weekly release. You should really be updating as often as possible to fix all these known vulnerabilities. And finally, I'll leave you with this. Vulnerabilities have a high cost even if you never get exploited. This is why CVE clean images are so important. It's hard to notice when you have 533 vulnerabilities in your image, when 534 get added, or 571, or 588. And your 11th or 12th or 13th critical CVE might not raise any alarms, even though it really should. If you do catalog your vulnerabilities, if you're keeping track of all of these things and watching them come in and go out, and regulated industries, many do, you're spending a ton of money to have somebody sit there and curate this spreadsheet of doom of all the CVEs coming in and going out, and was it fixed upstream, and is it really a thing? And that just on its own is costly and painful. So why not just not have the vulnerability? Can you imagine? Still, this is no silver bullet. Fixes take time to become available, even through chain-guard images. Immediate updates can be infeasible on your side for whatever reason. A shell, for instance, or a package manager may still need to be in the image, and so you can't debloat it all the way. And unfortunately, you still need to test your releases. But with that, I will give it over to my colleague, Jed. Take it away.
Hey, everyone. My name is Jed. I'm from Adara. We're new here, so hello, world. So as Jason mentioned, there is no silver bullet. I mean, that's essentially the point of this talk is, one is secure by design. Like we want basically software that you don't have to deviate from the defaults. You don't have to flip a bit to be secure. Like we don't want the, secure my ish flag. We want something to be secure just out of the gate. We want you to deviate from the default if you want it to be insecure. That's kind of the premise behind secure by design. And beyond that, there is no silver bullet. How many of you, just show of hands, run containers? Right. Are those containers isolated from each other? Aha, great question.
Mostly.
So we learned a lot about container images, and that is an absolutely essential layer in your stack. But shifting left isn't sufficient. It's not enough. We need to layer our security. The shift left was kind of presented at one point as the answer to security. And I think that most people have kind of recognized at this point that in and itself, it's not sufficient. You should be shifting left, and you should be thinking about scanning code and scanning for vulnerabilities, but that's not going to make your Kubernetes environment secure. So catching bugs earlier in the pipeline is a good thing. But really, I think what shifting left meant is that it put the entirety of the burden of security onto developers. And now we have terms like DevSecOps, which basically means that sounds, you're not just a software engineer, you're now a security engineer as well. So yeah, that model, unfortunately, isn't really viable. In addition to that, there's a lot of problems with shift left if it's really, your only, or even if you're depending on it for one of your main defenses, in that there's a lot of false positives. A lot of the vulnerabilities that come up are literally not legit. Most of them are not exploitable. And the difficulty of finding which ones are actually, worth your attention, there's been entire blog posts written by ChainGuard and others about that. So don't shift in any one direction. Basically, security is too complex for that. If your business runs on top of Kubernetes, then it's sufficiently advanced and nuanced that you need to really think about security almost at every layer, which is never really a popular topic. Everybody wants the silver bullet, but it just doesn't exist. So this doesn't cover, network policies, security monitoring, admission controller policies, using those images, using isolation. These are intrinsically good things, but don't throw these other things out. Use network policy. Admission controllers are crucial. You should be doing all of those things, basically. So this little pixelated Swiss cheese kind of advocates for the Swiss cheese security model. Has anybody heard of that? Basically, the concept is, you can kind of imagine an attacker trying to get through this, piece of Swiss cheese and kind of crawling through all of the different layers to get there. You have all of these defenses put into place in, minimal container images, but all of these other defenses are crucial as well. And the whole point behind this is that we really want to make our attackers' lives hell. We want to give them a bad day. If they want to come and own us, they're going to have to fight really hard to do it. And that's what we're building. So I'll give you an example. Let's say you do everything in your power to remove all vulnerabilities. You've completely shifted all of your container images over to, ChainGuard images. All of your images are rebuilt nightly. You're picking up those fast patches, and you have low to no CVEs, coming out of your scans, and shift left is all happy and everyone's good to go. But Kubernetes is a shared system. Clusters are shared between teams. Multi-tenancy isn't really the exception, it's the rule. Every Kubernetes environment that I've seen in the last 7 years is effectively a multi-tenant cluster. And not only are clusters shared between teams, but kernels are shared between containers. So when you're actually running your workloads on the Kubernetes node, they're all using the same shared kernel. And that shared kernel has access to all pod secrets. It's running the pod. It has basically full control over all of your workloads. So if another team with an image that isn't running an up-to-date distribution like Wolfie and has vulnerabilities, then all of your efforts to reduce CVEs and make shift left a success, with the right vulnerability, that won't matter because a single container escape can render your entire cluster untrustworthy, and you'll have to burn that infrastructure down and basically rebuild from scratch. So there are nuances here, and there are no easy solutions or no silver bullets. So I mentioned that containers have access to a shared kernel, and what we've talked about in this talk so far is basically the upper layers. Like, we're talking about container images, we're talking about Ruby, Node, Python. Those are all things that are absolutely crucial. But containers also have access to a kernel. In fact, every container that runs in a Kubernetes environment uses the same shared kernel. And that's a pretty large attack surface. People, as a result, are starting to do some pretty crazy stuff that we've seen out in the wild to solve for this. There was a recent Kubernetes podcast episode where they talked about container security. And the guest said, in relation to container isolation, I never say isolation with containers. I say segregation because it's a shared kernel. Like, you can't build a sufficient sandbox if you have a shared kernel. If you have a shared kernel, then basically the best that you can do is segregating your workloads. Otherwise, basically all of the one container gets compromised and it's game over for the entire cluster will remain true. So that's enough talk. let me show you a demo on what we've been working on. So let's see here. Alrighty. Okay, so I might have to peek over here. Okay, so what we see here is that we're running a single node cluster. So there's not multiple nodes. I'm going to show basically isolation inside of a single Kubernetes node. So no magic parlor tricks here. We can see that we have this single node running in EKS. Now, recently we released a tool that helps people understand the difficulty of isolation with containers. This tool is called Am I Isolated? And the whole goal behind this is to help the community educate themselves on the problems around container isolation. This is a very nuanced topic. There's a lot of tests here. This is a initial release. You can grab this on our GitHub repo. I'll provide the link if you're interested. Come and talk to me. But what this does is it helps us understand, how open am I to a risk from container isolation. If one container gets compromised because someone's doing a bad thing on my cluster, what does that mean for me? So what we're going to do here is we're going to apply a standard pod. It's called Leaky Vessel. And like every Kubernetes talk, we're just going to apply the pod before we read the YAML, because that's the secure thing to do. But what is Leaky Vessel? Nothing really. It's not super interesting. It's a pod that has a couple of environment variables. One is specified in the YAML. The other is baked into the image. These are secret environment variables. So what does Leaky Vessel do? Well, if we take a look at the logs, it doesn't really do much. It's just sleeping. But we're going to apply, again, before we read the YAML, Raider. And Raider is actually a much more pernicious workload. So what is Raider? Let's take a look. Looks like a pretty innocuous pod spec. But with the right grep, we can see that what it actually is it has basically a couple of really dangerous flags. One is privileged. If you're unfamiliar, basically this means that we're not going to run as a container. We're going to run as a Linux process, effectively. Like we're running a process typically as root, unless you use chain guard. You're not using root by default. And we also are mounting in the host process ID, or the host PID namespace. So I like to quote Mr. Lewis here, who says that privileged is basically the most dangerous flag in all of compute. So let's see what we can do with this. So if we run psfo as expected, because we're effectively running this as privileged, we can see all of the processes running on the Kubernetes host. We're not contained. We are just seeing everything just as a standard Linux process. So what can we do with that? Well, we can do some interesting things. The container that's running, that's exporting its environment variables, because we have access to basically the shared kernel, we can grab the process ID of that container with some bash magic. And with that process ID, we can actually look straight into the shared kernel and find the projected environment variables. So these secret environment variables aren't so secret. And this, again, is a result of the fact that containers are using a shared kernel. And the real problem here is that this is fundamentally the way that containers are architected. There's no way out of this sans rewriting the kernel. So let's dive in and take a look at the secrets specifically. There they are, just a simple grep. So how are we going to protect this workload? Well, of course, we can just delete it. Let's just get rid of it and pretend that this never happened. But what we're going to do is, again, apply this pod. We're going to apply something called hardened vessel. And this is actually using this new Adara isolation technology. Let's take a look and see what the difference is between the leaky vessel that we looked at earlier and ours. Really ignore everything with the exception of the runtime class that's named Adara. What that runtime class does is it basically when you run a pod, it runs it inside of its own isolated zone. If you want to talk about, in the questions like what the architecture looks like, I'm happy to do so. But it provides isolation from the shared kernel. It has its own kernel. So every pod basically doesn't share a kernel. It runs with its own. So again, we'll just make sure that we are running hardened vessel. And we're going to go back to Raider and do the same thing, psfo. We see all the processes on the host. However, where's leaky vessel? In this case, we've gone to hardened vessel. So we're going to do the same grep, and we can see that because we're not using the same shared kernel, because we've actually isolated this container inside of this zone, we don't actually see anything from it. So that's how we've achieved isolation at Adara. Like, we're basically very new, but that's a quick preview of what we've been working on. And most importantly, that's us. Woo. Okay, if you want to play with any of the, let's see, how do I get back to the other screen here? We are running a CTF, so for security enthusiasts who want to try and escape from this environment, we will be offering a modest bug bounty for those who are able to be confident in our architecture, but we love the community, and we basically want to improve container isolation and security across the board. You can find info at adara.link/CTF, or just come and talk to me after the talk. Thank you.
We have 5 minutes for questions. Okay.
I have multiple questions. I will start with one. We'll see if we have. Yeah. So we'll see if we have time. So most of the pods in Kubernetes that are using the privileged true flag or running in a host speed namespace are actually pods that are doing some infrastructure work on the cluster.
Yeah, CI.
Let's use the simplest example, Falco, as a runtime detection tool.
Mm-hmm.
How do you handle Falco? Because if you're separating it from the original host, then it won't be able to do any of its work.
Yeah, so each of it depends, right? Like if you're using eBPF, for example, for detection, we ship kernels for each of the zones, as we call them. So basically, you instantiate the zone, and then you give it a kernel so that it can run the container. You can ship that as an OCI image with BPF enabled. So you're still getting all of the data from that single container or maybe multiple containers per pod within that zone. And then you can take that data and just like, for example, something that looks like Tetragon or Sysdig, it'll use something like FluentD to just ship those logs out to some log sync, and then you can basically view the data from there. So it's really just shifting from like a shared kernel to a kernel per workload, and we can still get that same observability.
So if I understand, if you group together a number of workloads together under the same kernel, so in this case, Tetragon will see all the others in the same zone.
Yeah, so
but not the others.
So there's a kernel per zone, and there would be like a Tetragon instance running per pod in this instance. That would be observing basically one or more containers per pod, but it would only be observing the processes inside of that pod, inside of that one kernel.
Okay.
Great question.
How is this substantially different from, say, running KubeVirt?
Yeah, great question. KubeVirt is really meant to run virtual machines on top of Kubernetes. What that means is your virtual machine doesn't have isolation. It's running as a container, so any other containers that are running on that same system can access, the shared memory of that container. But it is running a virtual machine at the end of the day. What we're showing is basically, we're kind of Docker for Like you could basically just run Docker run or really any container image inside of this environment. So we're running containers, but we're giving them the isolation of virtual machines, if that makes sense. So KubeVirt's like running virtual machines on top of Kubernetes. We're running containers kind of under the hood as virtual machines for isolation, but they're still containers.
Okay, thank you for this presentation. I'm curious to know if you can explain us, in this case, how the memory isolation works with Eldera.
Yeah, so what we saw earlier was when we looked at when we looked at proc, proc had all of those environment variables in it because it's a shared kernel. So each container that basically uses that same shared kernel is using shared memory. In our model, we actually have a kernel per pod. So it's separated by a hypervisor. So that hypervisor is completely isolated from a security perspective from the host. Like the host doesn't have access to the memory from that guest running in the hypervisor. And the opposite is true. Like the hypervisor doesn't have access to the host. So it's kind of a, you don't have to trust your provider and you don't have to trust the workloads that are running in your environment.
So kind of as a follow-on to the KubeVirt question, how would you distinguish this from something like Kata?
Yeah, absolutely. Kata requires virtualization extensions. So basically, your hardware has to support virtualization. And that basically means that if you're running in a Kubernetes environment, you're deploying your nodes on top of bare metal. And bare metal has a lot of negative consequences, like it's extremely expensive. They don't exist in every region, in every cloud provider. And they don't support auto-scaling. So the vast majority of the folks that we talk to are running on, say, EKS, using auto-scaling, and they want that kind of like, best price on a standard EC2 instance. So what you're looking at here is para-virtualization, so basically virtualization without needing support from the hardware. So we can run on, a standard EC2 instance or an edge device or even a Raspberry.
Last one. No? Okay. Thank you very much.
Thank you.
Then we're going to continue. It's from Amit, and we're going to talk about building kubectl plugins like a pro.
Yes,
Okay.
yeah. Awesome.
One thing before you go, Amit was today at the Contributor Summit, and he asked for help for the kubectl
Plugin manager.
Yeah,
Yes.
so you can do the same thing.
Yes,
now,
we'll
right?
do the same. Okay, hello everyone, my name is Amit. So today we're going to talk about kubectl plugins. I'm probably going to say kubectl a few times. I might say kubecontrol a few times, just warning you, don't get too confused. kubeoctl is an option as well. So I'm an engineer at LinkedIn. I lead the cluster management group. Prior to that, I worked at Twitter, and before that, Google Cloud and Azure. So I've been in Kubernetes and container space practically all my career. This is my after 5 years, this is my first time of visiting KubeCon, so I'm very excited. You might know me from the open source, through various Kubernetes CLI-based tools that are rather popular among developer community. So today we're going to talk about the plugin machinery in kubecontrol. And then we're going to talk about Crew, the plugin manager in kubecontrol as well. And then we're going to talk about writing idiomatic CLI tools. And there we're going to have a lot of demos. I'm going to walk through a lot of code, so stay focused. Hopefully you got your coffee going. We're going to talk about flags. We're going to talk about resource querying patterns and stuff like that. And then at the end, I'll try to do what are my favorite kubectl plugins? Obviously, it's the ones that I wrote. So we'll talk about a few more. Okay. So is this talk just about kubecontrol plugins? The answer is no. A lot of CLIs out there query the Kubernetes API, right? istio-ctl does it, probably istio-ctl, whatever you call it. Knative has a CLI that does the same thing. I mean, an hour ago, there was a demo upstairs. Someone demoed the, Cloud Native Postgres, and they were showing a kubecontrol plugin as well. So these are like rather popular tools. So this talk is pretty much relevant to developing any CLI tool that is going to query the Kubernetes API at the end. So let's talk a little bit about the plugin machinery in the kubectl. But before we go there, I want to also explain why would you develop a plugin, right? Obviously, kubectl doesn't give you everything you want. So you want to create extensions to kubectl that feel the same way, right? Git has many of these extensions. You can install fancy Git plugins into your shell, and you type Git something, and it feels like it's part of the Git, as if it just comes in the package, right? So one fun thing that you can do is, if you work at a company that controls the developer environments, you can pre-install these tools to people's machines, and people will think, wow, this tool is just part of Git, right? I didn't install it myself. So we do the same thing at LinkedIn, actually. We have our own internal CLI that we install as a plugin into kubectl. It's called kubectl in, and a lot of internal developers don't install it themselves. It's just there, and they think it's part of the experience. So part of the goals of the project is to feel natural. So let's talk about the plugin machinery and how it works. Surprisingly, it's extremely simple. The plugins machinery was introduced in 2017, Kubernetes 1.8. That's really, really old at this point. And one thing that you can do is obviously add commands to kubecontrol, but you can't shadow the existing built-in subcommands. Like you can't create a kubecontrol edit that is your own. You can't create a kubectl create of your own. So main reason for that is obviously security. People don't want to replace the entire kubectl machinery with something that happens to be existing in your path. So the way again, plugins work is you create a binary or executable, could be literally a bash script, no one cares. As long as it's executable, you just put it in your path, somewhere in your path, doesn't really matter where. As long as it's called kubectl-foo, you can invoke it as kubectl space foo. Simple as that. Now again, if it has double dashes in it, or like the dashes in the middle, you can call it multiple ways. It can be kubectl foo space bar, or could be like foo dash bar. So this is again rather, it's open for interpretation. But if you want to unambiguously define it through a dash, you have to use an underscore in between. So that's kind of how the plugin machinery works, and it's super simple. There's practically nothing else you need to know about the plugin machinery to develop one or use one. Now, Kubernetes 131, which just released, introduced a new type of plugin system. It is called create plugins. So for a really long time, we've seen a lot of developers, a lot of vendors creating their own plugins, right? Like, for example, you have a Postgres operator. You distribute a Postgres CLI just so that people can have a create command. So now you can instead flip that Postgres create, and you can do create Postgres. So as a result, you can now create plugins that are prefixed with the create dash. Again, if you recall from the previous slide, you could not overshadow an existing subcommand like create, but now you can. Now the caveat there is it's not going to show up in the kubectl create list, but it might. I don't think anyone thought about contributing it, so it actually can be done. Okay, so this brings us to where do I find plugins? How do I package them and distribute them? So Crew Plugin Manager is a Kubernetes 6 CLI subproject. You can find the project at crew.6.case.io. So this project started as an intern project, actually. I had an intern at Google in 2018, and we were like, let's just develop a plugin manager. Why not, right? No one's going to do it if we don't do it. And then the project got accepted into 6CLI in 2019, a year later, and we maintain a hand-curated list of plugins. Like, we literally tell people, yeah, your plugin sucks, you can't submit that here. Or we tell them, yeah, this plugin is great, but did you think about like adding this feature? Or did you think about like changing your help message to look like this so that people can find your plugin better? So we actually spend time with plugin developers to curate that. Rather, it's not a pristine list per se. Like, we still accept a lot of plugins, a lot of stuff gets through over time, but it's a hand-curated list. Now, you might wonder, like, is that really a good idea? Because like Helm used to have these curated charts, and they actually abandoned them because it doesn't scale. And this is where I do my plug. We hand maintain these lists, and there's actually one maintainer that looks at these plugin submissions. So anytime a new plugin comes in, sometimes they wait in the queue for a week and a month until we realize that, turns out I forgot to check my email. Turns out it just got lost among my emails. So I don't realize that the plugin submissions came through. And it's concerning given that there are 275 plugins already distributed through Crew. So if you submitted a plugin and FI didn't answer timely, you now know why. So if you're interested, please contact. We're trying to establish some governance and guidelines around how do we accept plugins, how do we review them, and so on and so forth. Okay, so when plugin machinery first came out, we thought that, okay, we're probably gonna ever have 50 plugins, so let's not write the most perfect code that can be written. So there's a lot of crap that is in Crew today, and the community has proven us wrong over the years, and the plugin submissions to Crew only has been steadily increasing. Like, if you look at the trend line, it's sometimes above the curve, sometimes below the curve, but it's actually pretty much going pretty healthy, which is fairly interesting given like the stability and maturity stage that Kubernetes has reached, right? So as of, I think at this time, there's 277 plugins on Crew. But yeah, there's a pretty big increase. So every 6 months, I think we go something like, the 50%? No, something like that. Anyway, I forgot to do the calculation. Okay, so this brings us to the beefy part. How do I develop a CLI tool that feels like kubectl, right? You can certainly re-implement kubectl yourself, but we're not gonna do that. We're gonna build something using the reusable blocks from the open source, and we're gonna put them together, and hopefully this is gonna be an easy demo. So the demo is gonna be multiple pieces, but let's first try to understand how does it look like to feel like a kubectl plugin. Well, the first thing is you have your CLI options, right? When you do kubectl-help, you see some certain flags that are just everywhere. Like, even if you go to Helm CLI, if you go to, I don't know, istio-ctl, whatever, like all these flags are there. The -- context, -- namespace, right? All these standard flags are part of the experience. Like, it doesn't make you second guess what you're using because it's part of the experience that comes with kubectl. And then the second thing is the configuration and context awareness. So for example, if I have a kube-config file, which all of you do in your home.kube.kube/config directory, right? You can have multiple of that. Did you know? Like, you could actually list multiple kube-config files in the kube-config environment variable. But if the tool doesn't understand that you have a kube-config environment variable, well, all that goes out of the window, right? I can't just use istio-ctl if it doesn't respect the same environment variable. So the consistency is part of the story here. And similarly, we expect that the commands in other plugins or other tools will be organized using the verb and resource, just like kubectl create pod, kubectl scale deployment, right? So this is another area where we expect plugins to kind of look and feel the same way. And similarly, the common way of specifying resources. Like, let's say I want to query all the pods. What do I do? Kube-control get pods, -- all namespaces, right? So this feels natural. Similarly, I can query a service named foo. I can say service/foo. I can also say service space foo, right? So there are all these different ways of querying resources. You can literally specify -f deployment YAML. You can pass that to the delete command, and it finds the resource in the file, and it deletes that resource in the cluster, right? So when you develop a tool like that, it would be ideal to do so. So We're going to start with the generic CLI flags because this is the easiest thing you can do, and this is the first code that I'm going to show here. So when you type kubectl options in your machine, you're going to see that there are a lot of like common flags in every single kubectl subcommand, right? The -- context is part of that, -- namespace is part of that. So as a result, you get these like common arguments that configure how does the CLI find my cluster and talk to it, right? So as you can see in the code, this is very easy. You just import the CLI runtime, which is a Kubernetes 6 sub-project, and then they offer a generic CLI options package, and then you just add it to your command line flags, and you're good to go. Actually, I'm going to do that demo really quickly. So if I look at my code here, you're going to see that. Again, I have that exact code that I showed you. And if I, let's install this binary, and now Go compiler is really slow for whatever reason. I'm going to have it, because this project was called kubecontrol-demo, I'm going to have a binary called kubecontrol-demo. And guess what? It's not going to do anything. It's just going to, obviously, it's not doing anything, right? It's just parsing the flags and exiting. So if I do -help, this is where you see that this looks very familiar. This is like, all the context and, namespace, timeout, kubeconfig file that I had in the kubecontrol file, kubectl. Okay, so that's good. Now you're off to a good start already. Now, here comes the next step. Usually an empty CLI that does nothing is not a good use to anyone. So you need a client. You're trying to talk to the API server. You need to find the API server. And to do that, the first thing that you do is you get a REST config from the kubecontrol. And that's like, what is my API server address? Where is the certificate? What is the token that I'm supposed to use, right? And then you initialize a Kubernetes client set. So this is a typed client set, meaning we know the types like pods, namespaces, etc. ahead of time. And now, here in this example, I'm building a discovery client. And I'm going to create the server version of Kubernetes, right? So let's show you that demo as well. Let's check out the other branch. Let's check out step 2. Okay, so now we're in the step 2. So it's the exact same code that I showed you. I'm going to parse the Kubernetes API version from the server, and I'm going to just type it on the screen. So again, the flags are still there. Let's go ahead and compile this. Go install. Okay. Again, Go compiler is going to take its sweet time. kubecontrol demo. So because I'm talking to my local kind cluster, I'm just going to say it is 131 as expected, right? So all we did here was to initialize a client set. Now, one thing that you'll realize here is that I can do client set dot core v1 dot namespaces list, whatever Copilot tells you to write nowadays, right? It's very easy to get started using the typed clients because they're part of the client's Go, right? They're part of the built-in API, so you're having a pretty easy time here already. Okay, so let's go to the next step. Now, I want to select some resources. I was telling you, what if you could implement your own kubecontrol get command? I want to implement a fancy get, right? I've found ways to query pods by annotations or some other fancy thing. It doesn't really matter. All we're trying to find out is how do I query resources? So this is where the CLI runtime resource builder comes into play. So you just initialize it using the builder pattern that you're familiar with already. Then you pass your command line arguments to the resource builder, right? Like get pods, get services, or kubecontrol get service/foo. So all these are command line arguments. Or you can say that I'm not interested in all kinds of resources. I know the resource type. It's pods, and here are the names. Right? You can do that too. So that basically means your users can only query the pods, and the positional arguments to your CLI will be the pod names. So obviously, I'm not going to show that. I'm going to show the one in the middle. So let's go to that demo already. Hit checkout. Step 3. Okay, let's go to our main.go. Okay, so here's, this is the beefy part. So we initialize a builder, and then we told that, using this scheme that is already part of the kubectl, meaning the built-in resources, because I'm going to query pods. I'm not going to query CRDs with this yet. I'm going to show you how to do that too. I'm parsing my positional arguments to the resource builder, saying that this is either resource type, like pods, or it's the name of the resource. And I'm going to get a visitor function here. And the visitor function, basically, every time it finds a resource, it's going to execute this little block here. And this block basically is going to print the namespace, and it's going to print the object name and the object type. So because I'm going to query pods, you're going to see pods. Let's just go ahead and execute that. So go install. Again, this is Go compiler at work. So kubectl demo. Now, when I run this, I'm going to get an error because I didn't specify any positional arguments. But you know, the error looks very familiar. This is what happens in kubectl get as well, right? If I do kubectl get, what is going on here? Well, it says something similar. I don't know why the library says something different, but it's basically the same idea. So it basically says that in the demo plugin that I had, you should either specify a file name or some resource names and stuff like that. So let's go ahead and say kubectl, because I'm in my kind cluster, let's do kubectl demo pods. Okay, so this is exactly what I was expecting. Look, I didn't write any code. I didn't say go query pods. You know, you can say pods, you know, v1.pods. There are multiple ways to query these objects. There are like multiple ways to refer to them, and I already solved that problem. Like I can already use whatever kubectl uses, right? So one thing that you'll notice here is that these are already using all the namespaces. And like the command, I didn't tell command which namespace to use. And funny enough, there's probably actually a namespace command in the help message, right? There you go. But we didn't use that. It's because I didn't configure the code to do so. Another thing that you'll notice is that the type of the object that I got is a v1 pod. So meaning I actually got a Go object of pod type. What if I had CRDs? Like what if I work with any type of resource, like Istio resources, Knative resources, right? I couldn't do that because the built-in types do not allow that. So this brings us to our next topic. You either basically choose to work with a scheme or you work with custom resources, any type of resource that you have, and use the unstructured client. So what the hell is unstructured client, right? So unstructured client is basically just like it's not treating the API objects as Go types. It's leaving them as just maps. It's like, you know, unstructured JSON objects, right? But if you own your CLI and your CLI only works with custom CRDs, then you actually can still use the scheme method that I showed up there and register your CRD scheme and not do the unstructured objects. Because once you go to unstructured objects path, you're basically writing Python code, right? You're saying, okay, I'm going to go to the spec field, and spec field happens to be a map, and you're going to go to this array. So you're writing a lot of code to deal with the unstructured objects, which I actually did in one of my plugins, but it's fine. So this brings us to the next demo, which is basically using the unstructured. So how do I do that? Let's do git checkout. Step 4. Okay. So all I did was there was like something here that was saying with scheme, and I replaced that with unstructured. That's it. I just said I want unstructured. I don't care. So when I run this command, let's do go compile and kubectl demo. Okay, I forgot to add the pods. Now, as you can see, I'm getting a whole bunch of unstructured objects. So if I were to look inside them, I'm going to see that they're pods, but I have to reach to certain fields to read that, right? So this is great. You know, it basically is showing you that you can build whatever you want with this, and like you don't have to worry about whether it's a CRD or a built-in resource. You're already off to a good start. So this brings us to the next topic, which we alluded earlier, which is how do you figure out which namespace to use? So this is an area that admittedly the CLI runtime package falls short because there are multiple ways to pass namespace to a kubeconfig kubectl command. One is you can obviously say, I want -- namespace this thing. So obviously that should take precedence. Alternatively, you might say, I want all namespaces. Funny enough, in kubectl, you can specify both at the same time. And then lastly, there's this tool called kubeNS, or you can use kubectl config command too. You can switch into another namespace. You can say, for this cluster, this is my default namespace, so please assume this is the default namespace you should interact when you're creating resources or creating resources, right? So unfortunately, the existing code doesn't handle that, but thankfully, it's not too hard to do so. So I'll show you how to do that. This brings us to the next step, which is step 5. Okay, so the first thing that I do is register an all namespaces flag because it doesn't come out of the box. And obviously, I pass the flag. The next thing is I'm loading the kubeconfig file for this cluster. Just for this cluster, I want to understand what's in that config and whether there's a default namespace set, right? And after that, I'm like, if there's a -n flag, -- namespace flag, use that. If that's not there, use the one in the kubeconfig file, right? So that brings us to how do we configure that. Again, super easy. You basically say that this is my namespace, allow the default to happen, and whether there are -- all namespaces specified true, just use that, right? So let's try that real quick. I'm going to go with my terminal, go install kubectl demo. rather than the default namespace, you know, if that thing works, if I do dash kube system, another thing, printers. This is a pretty, you know, complicated topic, admittedly. So normally, you have to write your own printers, but recently there were print flags added to kubectl get that you could directly use out of the box. So this is not in the CLI runtime, but you can very easily add a bunch of flags about your printing functionality. For example, here I have, I'll go to that real quick as well. So here you can see that from kubectl get, we can add a whole bunch of print flags into our command set. And from there, as you can see here, in our visit function, we're just going to print the object. So if I show that real quickly as well, let's do go install. And then we'll do kubectl. Wow, this time compiler is really slow. Okay, kubectl demo pods. Actually, I'm going to show the help message first. As you can see now, we have some -- output, for example, right? So I can support JSON, YAML, whatever it is. And you get actually a lot more flags as part of that. So if I do kubectl demo pods, again, I'm getting these, you know, nice table. If I want YAML, I'll get YAML. Again, works, you know, just like how you expect it to be. You don't have to write pretty much anything. It's still like, we're still under like 50 lines of code. Keep that in mind. Okay, the next thing is server-side printing. This is another funny thing. So when I was just showing you the demo over there, did you notice that the kubectl get demo pods command actually didn't show you anything about pod readiness or like how are the pods doing? Well, that's because as of Kubernetes some version, I think 1.15, Kubernetes does the calculation of what columns show what value in the server side. That little running column over there, there's like 100 lines of code behind that little running column. And so don't try to replicate it. What you can do is you can still get it to work in your CLIs, and that brings us to our next step, which is kubectl. Actually, I'm running low on time apparently. Okay, 3 minutes. Yeah. Okay, so let's go to step 7, which is our last bit of code that I'm going to show you. So one thing that you can do here is you can tell the request builder that, sorry, I messed up the code. Actually, let's reopen the file. Okay, so you can add this little header, which basically says that I want my requests to come as table if the output is human readable, which is like output wide or table, whatever it is. And this basically says that send me a v1 table object, right? And the table object is, again, not a real API object. It's just something in the API machinery. If you go install, and if you do kubectl demo pods, boom, you're suddenly getting all the funny flags that you got from the server side. Okay, so that was pretty fun. We didn't show how to select from the file or selectors, stuff like that. More tips, adjust your client-side rate limiting. Your plugin, if it's querying a lot of stuff, you're going to run into rate limiting. And if you make a large list of calls, maybe like paginate them, so specify something like 1,000 so that you don't overload the API server with a lot of memory usage. So a lot of what I explained actually was in a blog post. I discovered that while I was writing the talk, unfortunately, and there are good examples. So take a picture of this slide. It's a good idea. Yep. So another set of recommended resources, again, basically what I showed on. I have some example plugins like Podzone, Con, basically do the same thing. Now, I'm going to blaze through some useful plugins, okay, in 1 minute. Who can? Okay, so this is something in Crew, shows you who can do what. Who can get secrets? Pretty fun. You can't do that with kubectl. Get all. kubectl get space all doesn't work because it only works with built-in API resources. This enumerates every single API resource type, so it shows all the CREs and everything. kubectl tree, this is something I wrote, shows you object hierarchies. Who owns what resource? That's kind of fun. kubectl for each, again, unfortunately something I wrote, but it lets you execute a command against multiple clusters. We use this all the time because it's super helpful querying like what's going on in my fleet. kubectl images shows you which pod, which container is running what image. kubectl needs, if you have an existing resource. If you want to export that to a nice YAML file with no boilerplate crap like generation and creation timestamp, whatever status, cleans up all that and puts that out there. kubectl con, this is something I wrote as well. It shows you conditions on objects. If you want to Scostalk, you'll see conditions are super useful. Blame, fields. These are also plugins that show you who edited which field. So you can see a pod was created by a kubectl manager, and its status, which field was updated by who and when. This is pretty useful as well. Thanks for coming to my talk.
We have 5 minutes for questions, so yeah.
I'm going to ask the controversial question. Suppose I'm developing a kubectl plugin in a different language that doesn't have like all of this nice stuff. I can imagine a world where kubectl itself is able to parse all of these flags, and then there's like some sort of communication to the subprocess where it's able to handle this stuff. Is that something that is
We
ever
haven't heard
feasible?
the demand for it because like 99% of the plugins are written in either Bash or Go. So that never really like came up as a feature request per se. But again, we're also lenient about how plugins look and feel. There are plenty of plugins that don't do anything I showed here, and they're fine, you know, as long as people can figure out how to use them. Scott says we should make that plugin. Actually, that's an interesting idea, yeah.
I've actually written a plugin like that. That's an internal CLI, or not a plugin, an internal CLI in Python that does a lot with like the Python typed clients.
Yeah.
One of the big points I've run into is with the port forward command, because I want to programmatically establish a port forward to do some operation. I hadn't realized until I got into the weeds that that was really a client side thing that's being done in kubectl and not server side. So I would support that kind of effort.
Yeah, I'm invalid, but I mean, feel free to propose that. Scott says something or any other question.
Do you have any general advice for when something should be a kubectl plugin versus when it should just be like Istio control or whatever?
If it's managing generic Kubernetes resources or like you have your own CRD, I think it makes sense to be a kubectl plugin. But a lot of, you know, Minikube is not a kubectl plugin. Neither is Helm, neither is Kind, because they don't manage Kubernetes resources per se. Like they do their own thing, and I think there is no like clear, you know, I can draw a line and this is plugin, this is not. We have like log tailing commands that distribute standalone, like Stern or Kale, whatever. But they also distribute as a plugin under a different name or something like that. So there's, you know, there's no free format.
We have a few more minutes for questions. Anyone? No? Okay.
Scott,
Yeah.
Scott really wants this.
Why did you reject my crew submission?
I rejected. I don't think I did. I don't think I did. Sweet.
All right. Thank you, Ahmed.
Thank you.
With that, that was the last one for this stream. We have one more in the theater, and don't forget to attend all the lightning talks after that. So thank you very much.
you.